Thank you for choosing American Pest CEUs. Hi, I'm Sean Reeves. I'm an Associate Certified Entomologist with American Pest CEUs. I've been in the pest management industry since 1999, and I'll be your instructor for today's course. Today's course was compiled by Jack Launius, who has served in the pest management industry since 1990. We only have one planet. In today's course, we're going to talk about pesticides in the environment. After studying this chapter, you should be able to describe how pesticide applications can affect the environment, explain how to prevent pesticide drift, runoff, and movement to non-target areas, identify sensitive areas that could be harmed by pesticides, discuss how to prevent pesticide residue accumulation associated with mixing, loading, and equipment washing, state when to adjust or delay an application to minimize environmental impact and maximize effectiveness. Applicators and the public share concerns about how pesticides may harm the environment. Initially, hazards to humans were the primary reason. The U.S. Environmental Protection Agency, EPA, decided to classify a pesticide as a restricted use product. Now, more and more pesticide labels list environmental effects, such as contamination of groundwater or toxicity to birds or aquatic organisms, as reasons for restriction. To register new pesticides, EPA requires manufacturers to submit extensive environmental tests. The agency also reviews environmental effects when reevaluating existing pesticide registrations. The environment. The environment comprises everything that is around us. It includes not only the natural elements that the word environment usually brings to mind, but also people, the manufactured parts of our world, and the indoor areas in which we live and work. The environment is air, soil, water, plants, animals, houses, restaurants, office buildings, factories, and all that they contain. Anyone who uses a pesticide, indoors or outdoors, in a city or on a farm, must consider how that pesticide affects the environment. So there's some really good points here. Obviously, we have to understand the environment is everything around us, and not only is it everything around us, but it's our responsibility as pesticide applicators to protect that environment. So each time you're planning or thinking about doing an application, you need to really think about the environment around you, and you need to keep in mind what's around and what issues you need to be concerned about in that surrounding environment. As we go through this course, we're going to detail a lot of things about the pesticide use in the environment and how we can all do better to protect it as pesticide applicators. The environment. Applicators must ask 3 questions. Where will the pesticide go after it leaves its container or application equipment? What effects could this pesticide have on those non-target sites it may reach? What can I do to minimize harmful effects? Pesticide characteristics. To understand how pesticides move in the environment, you must first understand certain physical and chemical characteristics of pesticides and how they determine a pesticide's interaction with the environment. These characteristics are solubility, absorption, persistence, and volatility. And you're going to really need to understand all 4 of these terms. Any of you taking core exams in any states are definitely going to hear terms like solubility, adsorption, persistence, and volatility. So just keep in mind those 4 terms are going to be very important as we go through this course. Let's start off by talking about solubility. Solubility is a measure of the ability of a pesticide to dissolve in a solvent, usually water. Pesticides that are highly soluble in water dissolve easily. These products are more likely than less soluble pesticides to move with water and surface runoff or through the soil. So there's some really good points here. Solubility is going to be that measure of the ability of a pesticide to dissolve in a solvent, usually water. So what that says is, just right up front, if you're putting a product out that's water soluble and you know there's rain in the forecast, what are you really doing? You're putting out there the potential for that pesticide to get carried off target. So it really doesn't make sense for us to put a water-soluble product out when there's going to be rain or something like that. Now you'll notice on a lot of pesticide labels, it says do not put product out when rain is imminent in the area. And this is the exact reason why. Now obviously products that are more soluble are going to move quicker with water than ones that are less soluble. So these again are going to be based on formulations and mixtures. So as you're studying pesticides, make sure you understand how mixtures and formulations relate to solubility with the product. Another important term in today's course is going to be adsorption. Adsorption is the process whereby a pesticide binds to soil particles. Absorption occurs because of an attraction between the chemical and soil particles. Typically, oil-soluble pesticides are more attracted than water-soluble pesticides to clay particles and organic matter in soil. Although pesticide molecules with a positive charge are tightly absorbed to negatively charged soil particles, a pesticide that absorbs to soil particles is less likely than one that does not absorb tightly to soil to move from the spray site. With absorption, we have to think about this. We have to understand what types of mixtures are going to be more likely to attach to that soil or bind to it. So we already talked about that those oil-soluble pesticides are more attracted than the water-soluble pesticides to clay particles and organic matter in soil. So we already know something that's oil-based is going to absorb to that soil better than a water-based product. And just note, a pesticide that absorbs to soil particles is less likely than one does not absorb tightly to soil to move from the spray site. Many things we're looking at when it comes to pesticides has to do from runoff. Will the product run off to a non-target area? And as we think about it, absorption is one of the biggest factors in this. So once again, you have to watch your formulations. You have to understand the absorption rates of the products and understand what's in your surrounding area. If you're by a body of water or you're by a storm drainage sewer, you need to understand that if you don't have good absorption, when it rains, that product could very easily be carried off-site and end up in a lot of places you don't want it to. So just continue to study this absorption and how pesticides work with it. Another term that's very important in our core studies on pesticides is going to be the word persistence. Persistence is the ability of a pesticide to remain present and active in its original form for an extended period before breaking down. A chemical's persistence is described in terms of its half-life, a comparative measure of time needed for the chemical to break down or degrade. The longer the half-life, the more persistent the pesticide. The pesticide that remains in the environment after an application or spill is called residue. And again, this is a very important term, this term persistence. Any of you taking core exams in any of the states, as I always say, there's going to be certain things on there, and the term persistence is usually on there. And just understand that persistence is that ability of a pesticide to remain present and active in its original form for an extended period before breaking down. So you'll hear people talk about how persistent is a pesticide or how long does it last. So there's another word you're going to hear about as you go through these studies called residual. Is it a residual product? Well, the persistence of the pesticide in the environment is going to tell you a lot about how long the residual is. Just keep understanding that persistence is how long it lasts out in the environment, and also understand that persistence is very important because the persistence of the pesticide has a lot to do with pollution, runoff, and things like that related to the pesticide being active for a long time. As you can imagine, the longer a pesticide is persistent in the environment, the more the chances are it could do harm to that environment. Sometimes residue is desirable because it provides long-term pest control and reduces the need for repeated applications. However, some persistent pesticides can harm sensitive plants or animals, including humans. Therefore, it is especially important to prevent persistent pesticides from moving off-site through improper handling, application, drift, leaching, or runoff. I like this term residue here because the reality is it does provide more long-term pest control. So that persistence and that residue left behind is providing us with longer-term pest control. And we need that because we don't need to make repeated applications all the time. So you hear a lot of people say when they're doing a pest control or weed control service, we come out monthly, we come out every other month, or we come out quarterly. The reasons why that is because the product's going to last for a specified period of time, at least in theory. We know other environmental conditions like rain and other things can break them down. But the point is, we need this residue and we need this residual effect. You can't do a quarterly pest control service if the product only lasts 2 weeks. So there are some good things with these residues. We just have to understand they can also harm sensitive plants or animals, including humans. So we have to make sure that they don't move off site. We've already kind of talked about that. But you definitely don't want these pesticides moving off site through things like improper handling, application, drift, leaching, or runoff. And these are things you can learn about by reading the label and just understanding your formulations and different types of products. Obviously, through handling, you don't want to have a chemical spill or anything like that. But when you think about drift, I mean, that's a whole nother issue. If the wind's blowing 30 miles an hour, do we really want to use a ULV product that's just going to be picked up by the wind? Absolutely not. And of course, the leaching down through the soil, which we talked about a little bit earlier, is that product going to leach right through the soil? Is it a sandy soil where it's just going to leach right down to the water table? Or is it more of a clay and more highly organic soil where it's going to bind more through that absorption? So just keep in mind, you're going to continue to hear these different terms and you have to continue to study them in your pesticide career. Besides presenting a hazard to persons and non-target animals entering a treated area, the application of persistent pesticides may produce illegal residues on rotational food or feed crops. To protect consumers, there are legal limits on how much residue may remain on products sold for food or feed. Check the label statements about the persistence of the pesticide and for replanting restrictions. The rate of pesticide breakdown relates to the persistence of the pesticide. So keep in mind, those of you dealing with food or feed crops, you have a whole nother responsibility here. You're trying to protect consumers, so there's going to be legal limits on how much residue may remain on products sold for food or feed. So you have to understand what those are. If you're out applicating with pesticides, herbicides, things like that, if you're putting too much on there and that gets tested and the level's too high, that's something you're not going to be able to sell. So there's a really big responsibility, obviously protecting human health with that, but also for your crop itself. If you put out too much and that crop is no good, at that point you're not going to make any money on it. And those of you that are in agriculture, I know it's very hard to turn a profit at times anyways. You definitely don't want to deal with something like this. The other thing you do need to check is the persistence of the pesticide and for replanting restrictions. So when you use a pesticide in an area, if it says you can't replant there for 6 months, don't replant in that area. That means that product will probably get picked up by the new plants. It'll be systemic. And then once again, if that product gets picked up, then all of a sudden you're dealing with a higher level because you're going to go and you're going to do your pesticides again. The problem is it's already in the soil, so now you're doing another pesticide application, and in that agricultural product or plants picking that up, so now you've got more pesticides in that plant than there should be. So just keep in mind that that's something you have to be aware of, especially in agriculture. The other thing that's important here is the rate of pesticide breakdown relates to the persistence of the pesticide. So you have to understand how quickly it breaks down relates to the persistence. So something that breaks down quickly is not really a persistent pesticide, whereas something that could stay in the environment for weeks, months, even years, then we're definitely dealing with a persistent pesticide, and we need to be very careful and understand the impacts of that product. Pesticide breakdown. Several processes break down pesticide compounds into simpler and often less toxic chemicals. Some pesticides break down very rapidly, in a matter of days or even hours. Others linger in the environment for a year or more. Pesticides are broken down or degraded by the following processes. Chemical degradation. The breakdown of chemicals that do not involve living organisms, usually by a chemical reaction with water. Microbial action. The breakdown of chemicals by soil microorganisms, such as fungi or bacteria. Photodegradation. The breakdown of chemicals in reaction to sunlight. Water and temperature both affect the breakdown of pesticides. Warm, wet conditions can increase the speed of pesticide breakdown. Cool, dry conditions slow down the degradation process. We should look for places to use pesticides in areas where they are less likely to be affected by rain or sunlight. This is a good first step when slowing down chemical and photodegradation. And just to give you a quick idea here, you might want to put pesticides in areas around a house on the exterior, like in the eaves or in the soffit areas. I understand you have to think about drift and wind and things like that, but if we can get the pesticides in areas where the rain and the sunlight is not going to hit them as quickly, they're going to last a lot longer. So just keep in mind where we put the products has a lot to do with this chemical and photodegradation. Another idea is when you're performing an interior service, treating somewhere like a wall void can be a great way to make sure our products are not subjected to unnecessary water from house cleaning. Also, this would help with photodegradation. So again, we don't have to worry about chemical degradation, we don't have to worry about photodegradation, because we're putting the product in an area where it's not going to come into contact with anything. The other good part about it is as well, is that product is going in an area where humans or non-target animals aren't going to touch it either. So any way you look at it, when you do put these products in the right areas where the rain, sun, and non-target animals and species won't contact them, you're always going to win. They're going to be more effective for a longer period of time, and they're definitely going to be more safe as well. Next, we need to look at volatility. Volatility is the tendency of a pesticide to turn into a gas or vapor. Some pesticides are more volatile than others. The chance of volatilization increases as temperatures and wind increase. Volatility is also more likely under conditions of low relative humidity because evaporation increases in drier conditions. What we're saying here is with volatility, and you definitely want to understand this for core exam questions, some pesticides are always going to be more volatile than others. What we're saying here is, and you're definitely going to want to understand this about volatility when it comes to core pesticide exam questions, volatility is definitely that tendency of a pesticide to turn into a gas or vapor. So basically what the pesticide's doing is it's just vaporizing up into the air. Now the chance of this is going to increase as temperatures and wind increase. So we have to understand that volatility is going to be higher as the temperature and the wind increases. I see that on a lot of core pesticide exams. Also, it's very important to note that volatility is going to be more likely under conditions of lower humidity. So that drier air is going to cause evaporation, kind of like a lake or something in the desert, right? You know, when it gets really hot and it's dry, that water just continues to evaporate, and that's why we don't have a lot of lakes and things like that in deserts, because of the fact that that evaporation just pulls that water up into the air. And it's no different with the pesticide. Those mixtures are the same way. As that heat increases, as the humidity gets lower, it's just going to volatilize or vaporize up into the air a little easier. In our next section, we're going to look at how pesticides move in the environment. Pesticides may move from targeted application site in several ways: in air, in water, attached to soil particles, and on or in objects. Let's talk about movement in air. Pesticide movement away from the application site by wind or air currents is called drift. People who mix, load, and apply pesticides outdoors are usually aware of how easily pesticides may drift off-site. Those who handle pesticides indoors may not realize how readily some pesticides move off-site in the air currents created by ventilation systems and by forced air heating and cooling systems. Pesticides may travel off-site as spray droplets, vapors, dust or solid particles, and even on blowing soil particles. So we have some simple concepts here. Obviously, wind or air currents can pull pesticides into the air. This is called drift. So that drift is one of the easiest way for pesticides to be carried off-site into non-target areas. Some key points here are the fact that people who mix, load, and apply pesticides outdoors are usually aware of how easily pesticides may drift. I'm just going to use an example. If you have a dust product and you try to mix it outside and you pour that dust into like a puff duster bottle or something like that, you're going to see that dust kind of disperse up into the air. And just think, if the wind's blowing hard, that's really going to get carried off quickly. Now, these dusts can be highly toxic for things like honeybees, so we really have to think about when we're doing a product mixture outside or we're using a product, what that wind is like and how it can affect those non-target areas. An interesting thing here that I think most people don't think about is the fact that ventilation systems and forced air heating and cooling systems can also move pesticides off-site. So these types of systems are basically taking air from inside your home and exchanging it with outside air. So there is the risk of the fact that those air systems could pull pesticides into the air from inside your house by removing and exchanging that air. And just remember, pesticides can travel as spray droplets, vapors, dust, or solid particles. Understand that there's many different ways. We talked about the vapors, but the dust or solid particles, obviously, we talked about the dust. And solid particles could even be something like soil that has pesticides on it being blown by the wind. Those of you that live in the central part of the U.S. are used to those heavy winds. You have these different wind storms, dust storms maybe some people call them. But at the end of the day, think of it like this. If that dust is getting picked up and it's had a pesticide application, what are we having? We're actually having that dust get carried away up into the air with the pesticides on it, which of course is going to take it to non-target areas. Next, let's talk about movement in water. Most pesticide movement in water is either by surface movement off the treated site, runoff, or by downward movement through the soil, leaching. Runoff and leaching may occur when too much pesticide is applied or spilled onto a surface, too much rainwater or irrigation water moves pesticide through the soil, off-site, or into groundwater. Highly water-soluble or persistent pesticides are used. On this slide, we've introduced another term that we mentioned briefly earlier. The term is leaching. This is going to be the downward movement of the pesticide through the soil. You're definitely going to want to understand what leaching means because, again, this will be on a lot of your core exams. Now, when we talk about runoff and leaching, as we have here, just understand, if you use too much pesticide on a surface, this is going to be a problem. Obviously, if you spill it, it's going to be a problem as well, because then it would be concentrate, and we could have another big mess on our hands. Too much rainwater irrigation is another way that the water moves the pesticide through the soil, and it can go off-site and even into groundwater. Highly water-soluble or persistent pesticides being used, so just keep in mind, if you're using highly water-soluble or persistent pesticides, the chances of them moving in water are going to be a lot more. Runoff water in an outdoor environment may move into drainage systems, streams, ponds, or other surface water where the pesticides can travel great distances. Pesticides that leach downward through the soil may reach groundwater. In an indoor environment, water containing pesticides can flow into floor drains and contaminate water systems. A careless act, such as dumping a pesticide or rinsate down a sink or toilet, may contaminate an entire sewage or water treatment facility. Some pesticides can leach indoors. In a greenhouse, for example, pesticides may leach through the soil or other planting medium and contaminate other greenhouse surfaces. Look for special instructions on the label that warn of pesticide hazards caused by the movement of pesticides in water. Sometimes labels require buffers or setbacks from water and wells. One quick thing on this slide you do want to know, make sure you understand on your pesticide labels and your state laws what the setbacks are going to be from water and wells. A lot of your pesticide labels will mention water and wells, and if you don't look at those labels and understand what the setbacks are, you're going to misapply those products, and then you're in risk of contaminating water and wells, which is definitely something you don't want to have to worry about. Take a few moments to review this diagram. This diagram shows various ways chemicals break down or move or translocate to other areas. So how else can pesticides move? Movement on or in objects, plants, or animals. Pesticides can move away from the application site when they are on or in objects or organisms that move or are moved off-site. When pesticide handlers bring or wear home contaminated personal protective equipment, work clothing, or other items, pesticide residues may rub off on carpeting, furniture, and laundry items, and onto pets and people. One thing that I would note from this slide is the fact that your work clothing is a major issue. When you've been out doing pesticide applications, make sure you take that clothing off right away and make sure you launder it away from other clothing. Don't go sit down on your couch and other areas in your home and get those pesticides spread on your furniture. That's definitely something you do not want to subject you or your family to. Preventing pesticide drift. Studies have shown that a sizable percentage of pesticides may never reach the intended target site because of drift. Significant drift can damage or contaminate sensitive crops, poison bees, pose health risks to humans and animals, and contaminate soil and water in adjacent areas. It is impossible to eliminate drift, but it is possible to reduce it to a tolerable level. Let's talk about spray drift. Spray drift refers to the off-target movement of a pesticide during a liquid application. This is the result of small spray droplets traveling off-site on air currents. Spray drift occurs more frequently than vapor drift or particle dust drift. You can avoid most spray drift problems by paying close attention to spray droplet size, wind direction, and wind speed. Large spray droplets are less likely to drift than smaller ones. Selecting the proper nozzle and pressure is important to reduce drift. High pressure and nozzles with smaller orifices or openings produce small droplets likely to drift. Conversely, large nozzle orifices and low pressures produce larger droplets. So when we talk about spray droplet sizes, just remember your nozzle is a big part of it. If you've got a smaller nozzle with higher pressure, you're going to get smaller spray droplets that are more likely to drift. Now conversely, as we talked about here, you get a larger nozzle with a bigger opening and even lower pressures, you're definitely going to have larger droplets. And as you can imagine, those larger droplets are going to be heavier. So with the wind, there's less chances it's going to drift. Now, you got to understand what the wind is before you do an application anyway. So if it's a really high windy day, you can have a problem with either one of these. But the point we're making here is just remember, smaller nozzles, higher pressure is going to be smaller droplets that are going to drift easier. Larger nozzles with lower pressures are going to be bigger droplets that aren't going to drift as easily. Classification of droplet size. Nozzles produce a range of droplet sizes, known as the droplet size spectrum. Regardless of the type of nozzle used, a percentage of droplets created by a nozzle will be small enough to drift. Modern nozzle designs are excellent options because they reduce the amount of droplets prone to drifting during an application. A droplet size classification system can help describe the droplet sizes produced by a nozzle. This standard, S572.1, Spray Nozzle Classification by Droplet Size, established by the American Society of Agricultural and Biological Engineers, classifies nozzles into 8 categories. Using these categories, you can select a nozzle, orifice size, and operating pressure that produce a label recommended droplet size spectrum. Consult the label for the droplet size specifications that may be in place for a particular application. This chart gives you the information to select the proper nozzle for an application. Brass spray tips typically have the size stamped on the end, while plastic tips are color-coded. Please take a few moments to review this chart. Thus reducing the chance of off-target movement. Fine spray droplets may begin to evaporate before reaching their target. These droplets become very small and light and may move off-site. Modern drift control additives will decrease drift potential without dramatically shifting the droplets to a larger size. Remember, however, to always follow the label directions about using a spray adjuvant intended to minimize drift. Some drift control additives may actually increase the drift potential of an applied tank mix. Also, be aware that large spray droplets may reduce coverage, resulting in less pest control. Other factors. Wind speed and direction are the most important environmental factors influencing spray drift. Labels may indicate maximum and minimum wind speeds for application. Except in the case of temperature inversions, see below, the early morning and evening are often the best time to apply pesticides. This is because windy conditions are more likely to occur around midday when the temperature near the ground increases. This causes hot air to rise quickly and mix rapidly with the cooler air above it, favoring drift. The best time to spray is when spray droplets move slowly upward in the absence of windy or inversion conditions. Quick thing you want to note on here is early morning and evening hours are definitely the best times to apply pesticides. I understand a lot of you can't do that. You got a lot of customers to take care of. You're busy out in the field. So if you can plan pesticide applications around those times, at least as much as possible, it's better. Especially in the summertime when it's really hot in the midday. It's better if you keep your schedule a little busier earlier in the morning and even a little more towards the evening. It's better for things like heat stress as well, because if you're out there working and the heat index is up in the hundreds, you also can have problems with heat illness. But I understand it's tough when you run a business out there. Just try to do applications around those times of day as much as possible. Low relative humidity and/or high temperatures can also increase the potential for spray drift. Under these conditions, the evaporation rate of water increases, resulting in smaller spray droplets that drift more easily. Avoid spraying during these times. The height at which the pesticide is released above the ground or target may also affect drift. Applications that use large droplets close to the ground often produce little drift. Aerial spraying and tall tree spraying, on the other hand, are more likely to produce spray drift because they intersect large distances of air far from the ground. Drift from boom sprayers can be reduced by lowering the boom height to within 20 to 24 inches of the target crop. We talked about this earlier. Lower RH, or relative humidity, and high temperatures are going to increase that potential for spray drift. Not to mention the fact that volatilization is going to be even heavier during these times, as we talked about earlier. You would easily understand as well, if you're doing an aerial application from a plane, obviously, because that product's being released from that high in the air, the chances of drift are going to be pretty heavy. So that kind of goes without saying. But let's say you're treating trees or something like that. You're treating way up in the air. Maybe you're applying 15, 20, 30 feet from the ground. Obviously, again, it's a lot easier for you to have drift issues when you're treating that high up in the air. So as much as we've talked about this, we need to talk about how to decrease the outdoor drift. We can decrease outdoor drift by spraying when the wind speed is between 3 and 10 miles per hour, spraying downward from sensitive areas such as residential properties, schools, crops, waterways, or beehives, using proper nozzles and pressures, using drift control additives if appropriate, lowering boom height, leaving an untreated border or buffer area in the downwind target areas. We can also decrease outdoor drift by thinking about indoor applications. To reduce drift indoors, pest control operators must consider the air circulation patterns inside buildings. Turn fans and air conditioners off and close vents where necessary to prevent pesticides from drifting to other parts of the building. Use low volatile and non-volatile pesticides and low pressure treatments to reduce indoor pesticide drift. A temperature inversion is an atmospheric condition where the temperature increases with height. This could be described as a layer of cooler air near the ground trapped by a warmer layer of air above it. A temperature inversion exists when the air at ground level is cooler than the air above it. Under these conditions, the air is considered stable because there is little or no vertical air movement. Almost all air movement during an inversion is sideways or lateral. This causes a high concentration of small spray droplets to be suspended in this layer of cool air near the ground. These droplets can then be carried long distances, especially if wind speeds increase. When the spray droplets settle out, they may still be concentrated enough to cause damage or harm. Inversions may occur at any time of the day and at any height above the ground. However, they most often develop during the early evening hours as the ground temperature begins to cool and the warm air has already risen. And take a moment to look at the two images on this slide to see what that looks like. Inversion conditions intensify during the night and may persist until mid-morning when the ground is warm enough to start the vertical mixing of air, i.e. the wind starts to blow. This causes a dilution and separation of suspended spray droplets. Consequently, applications made during early evening, night, or morning hours under seemingly ideal conditions may result in highly damaging drift that can move long distances. This is especially true if the humidity is high. Such movement could occur up to 1 to 3 hours after the application. You can recognize these stable air conditions inversions by observing the movement of dust or smoke. If dust or smoke rises little from its source and tends to hang in the air, an inversion may be present or developing. Another way to detect inversions is to place one thermometer at ground level and a second thermometer high above the ground. Then compare the difference in temperature. If the temperature at ground level is below that found at the elevated thermometer, a temperature inversion exists. Do not apply pesticides under such conditions. When we look at vapor drift, this refers to the movement of pesticides as gaseous vapors from the target area. Some pesticides are volatile. They change readily from a solid or liquid form into a gas under the right conditions. This usually occurs in hot weather. Pesticides that have volatilized into a vapor or gas may drift farther and for a longer time than they would have as spray droplets. Only those pesticides that are able to volatilize are susceptible to vapor drift. As air temperatures increase, the likelihood that these pesticides will volatilize and drift also increases. Whenever possible, choose a pesticide formulated as a low volatility product. Do not apply volatile pesticides on hot days. Some products may even volatilize several hours after application, so be aware if high temperatures are predicted for later in the day. Many product labels advise against applying these products when temperatures are at or above 85 degrees Fahrenheit. Remember to check the label precautions for product-specific concerns about vapor drift. Particle drift, also known as dust drift. Particle drift refers to the movement of solid particles from the target area in the air during or just after an application. These solid particles may include pesticides formulated as dust or soil particles to which pesticides are attached. Some pesticides can remain active on soil particles long after they are applied. If particles are blown off the target site, sensitive areas may be contaminated or damaged. To prevent particle drift from outdoor pesticide applications from entering nearby buildings, Be sure to close all windows and vents. Turn off all circulating fans, forced air heating systems, and air conditioning units. For indoor pesticide applications, reduce particle drift by turning off fans, forced air heating systems, and other air circulating equipment. Check pesticide labels for statements related to these concerns. Couple of quick things to note here. If we're doing an outdoor pesticide application, we definitely don't want it to enter nearby buildings, so you need to look at things like windows and vents and just make sure they're closed. It'd be really easy for a product to drift into those areas. Also, we talk about here turning off circulating fans, forced air heating systems, and air conditioning units, because once again they're pulling air in from outside, they're exchanging the inside and outside air, so this is an issue that could bring the pesticides in. Now obviously for indoor pesticide applications, reducing that particle drift by turning off fans, forced air heating systems, and other air circulating equipment is helpful. Also think of it like this. If you were doing a service and you were putting a dust in an attic, like an insecticide dust, you would want these things turned off anyway. You don't want a forced air heating system or an air conditioning system running when you're putting a dust in that area, because obviously it could carry it throughout the house. We would definitely be remiss if we didn't talk about applicator responsibility. As an applicator, you are legally responsible for any damages resulting from the off-target movement of pesticides. Assess the vulnerability of neighboring properties and those areas downwind of the application site. Evaluate weather conditions for temperature inversions, wind direction, and wind speed before making the all-important decision about whether to spray. You may have to adjust your application equipment to reduce spray drift. Consider using low volatile formulations or adding a drift control agent or thickener to help minimize drift. If you apply pesticides indoors, you are also responsible for preventing drift. Ensure that pesticides do not move beyond the target site. All people and animals are kept out of the treatment area according to label instructions. Let's talk about sources of water contamination. Surface water or groundwater contamination results from either point source or non-point source pollution. Non-point source pollution from pesticide applications is usually blamed for pesticide contamination of the outdoor environment. However, studies show that water contamination may also result from point source pollution. So let's talk about what the differences are between point source and non-point source pollution. This is going to be very important for you as an applicator, as well as if you're taking any core exams. These questions come up regularly. Point source pollution comes from a specific identifiable location, such as a pesticide spill entering a storm sewer, back siphoning of pesticides into water supplies, contaminated surface water entering sinkholes, repeated spilling of pesticides at mixing and loading sites, careless spilling of wash water at equipment cleanup sites, improper handling of spills and leaks at storage sites, improper disposal of containers, rinsate from containers, and excess pesticides. Non-point source pollution comes from a widespread area. An example is the movement of pesticides into streams or groundwater after broadcast applications to large agricultural fields, rights-of-way, or turf areas. Pesticide contamination of surface water. Surface water is often a source of drinking water. Therefore, pesticide contamination of surface water, such as ditches, streams, rivers, ponds, and lakes, is a health concern. Pesticides that move in runoff water or with eroded sediment may contaminate plants and animals located downslope and reach sources of surface water. Now, every one of you understands why we need to protect surface water. Obviously, a lot of times it's even a source of drinking water. I do want you to understand that a lot of your states are going to have specific laws when it comes to surface water. So as you're getting ready to take exams or even need to just know the laws to do applications, make sure you understand your state laws as it relates to surface waters. They can be a really big deal. I can tell you, I took exams in New Hampshire and seemed like about a third of the exam was about surface water. But keep in mind, it's your job to understand those state laws, but also just make sure you're protecting surface waters. As you can imagine, once we pollute our surface waters, we're really in trouble in this country. Factors affecting runoff and erosion rates include slope, vegetative cover, soil characteristics, volume and rate of water moving downslope, temperature, and rainfall amount and intensity. These factors influence how much water runs off and how much moves into the soil in filtration. In urban areas, runoff may occur on hard surfaces where granules are left on sidewalks and streets. Runoff is a potential problem for most outdoor application sites. In areas treated with any type of pesticide, it is critical that runoff does not carry the pesticide into water sources or other vulnerable areas. Generally, runoff risk is greatest when heavy rains immediately follow pesticide applications or when the ground is saturated or frozen. Although surface waters are most likely to be contaminated by runoff, groundwater may also be affected when surface streams connect with shallow groundwater. We talked earlier about the fact that you don't want to do a pesticide application when rain is imminent in the area, and especially not while it's raining. The other thing that we introduced here is if the ground is already saturated from previous rains or frozen, you can imagine that product's going to run off a lot easier. As a matter of fact, I looked at a termiticide years ago. We were trying to do a termite treatment, and I looked on the label, and because the ground was frozen, I realized we couldn't use it. We were out there with picks and shovels and trying to beat through the ground, but the reality was the label itself said if the ground is frozen, you couldn't put out the termiticide. If I hadn't read that label, I wouldn't have known this, so just keep in mind when the ground's frozen, saturated, or any of these things we're talking about, you don't need to do a pesticide treatment. Let's talk about pesticide contamination of groundwater. Groundwater provides 70% of the water used for public and private water supplies, irrigation, and industry. Like surface water, groundwater must be protected from contamination. Once groundwater is contaminated, correcting the problem is difficult or even impossible. Groundwater is found underground in cracks, in the bedrock, and in spaces between soil particles, gravel, and rocks. It is the source of water for wells and springs. The layer of soil and gravel or fractured bedrock in which all available spaces are filled with water is the saturated zone. The boundary between the saturated zone and the underlying unsaturated rock and soil is known as the water table. The overall geologic formation from which groundwater can be drawn is called an aquifer. And this is the point where leaching comes in. Some pesticides reach groundwater by moving through the soil in a process called leaching. A pesticide that leaches into groundwater must move down through the soil and water and resist binding to soil particles and breaking down into non-toxic compounds. Pesticides that have high solubility, low absorption, and are persistent are more likely to leach. They typically have a label statement describing these concerns. A pesticide that absorbs or binds itself strongly to soil particles will not leach as easily. Besides the characteristics of the pesticide, soil properties and environmental conditions also affect whether and to what extent a pesticide will leach. Leaching, very, very important. Make sure you understand leaching. Make sure you understand when we talk about the pesticides binding to soils. We talked a little bit earlier about the different soil types. Some of them they're going to bind a little better to, like clay and heavy organic soils. But at the end of the day, you definitely need to understand leaching and the different types of soils you're going to be working with. The biggest thing about leaching is we don't want those pesticides to make their way down to the water table in the aquifer, because once again, a lot of times this is where our drinking water is coming from. So as much as you're doing this to protect yourself and your job, you're really doing this to protect the environment around you. Let's take a look at the properties of soil. Soil properties. 4 soil properties that affect a pesticide's potential for leaching are texture and structure, organic matter, depth of groundwater, and geology. Texture and structure. Soil texture is the relative proportions of sand, silt, and clay-sized particles. Percolating water moves faster in sandy soils. Sand also has fewer binding sites available for the absorption of dissolved chemicals than do clay or silt soils. Though sandy soils are more prone to pesticide movement, leaching may also occur in clay or silt soils. What we're saying here is sandy soils are going to allow that pesticide to move quicker through the soil so it doesn't absorb to the soil as much. So you have to understand when you're working in the sandy soil, that pesticide is going to go down really, really quickly. Whereas when we're working with clay and silt soils, especially if they have higher organic matter, that pesticide's not going to leach down into that soil as quickly. You always have to understand the type of soils you're working with and what the potential for leaching is. Soil structure is the shape or arrangement of soil particles. It plays a big role in determining the size and shape of the pores through which water moves. Small amounts of pesticides may also move through soil cracks, wormholes, and root channels. These features are called macropores. Let's talk about organic matter. Organic matter consists of decaying plant material. The higher the soil organic matter content, the greater the ability of the soil to hold both water and absorb pesticides. Pesticides held in the root zone are less likely to leach into groundwater and may be taken up by plants. Remember this. This is on almost all core exams in almost any state I've taken them in. The higher the soil organic matter, the greater the ability of the soil to hold both water and absorb pesticides. So when you hear about leaching and you hear about absorbed pesticides, just remember that higher organic content in the soil is going to make the pesticide stay there longer and not leach down to the water table. Depth to groundwater. Areas with a shallow water table have a greater chance for groundwater contamination because less soil is available to act as a filter. There are fewer opportunities for pesticide degradation or adsorption. When using pesticides in areas where the groundwater is close to the surface, choose a product with a low leaching potential. Take extra precautions during mixing, application, and cleanup. Geology. The permeability of the geologic layers lying between the surface of the soil and the groundwater is also an important factor. Highly permeable materials, such as gravel deposits, allow water and dissolved pesticides to move freely downward to groundwater. Layers of clay, which are much less permeable, can inhibit and slow the downward movement of water. Preventing surface water and groundwater contamination. To help prevent surface water and groundwater contamination, EPA requires all pesticide products labeled for outdoor uses to include the following environmental hazard statement on the label. Do not apply it directly to water or to areas where surface water is present or to intertidal areas below the mean high water mark. Do not contaminate water supplies when cleaning equipment or disposing of equipment wash waters. Pesticides that could contaminate groundwater must bear groundwater warning statements on their labels. When such statements appear on product labels, choose pesticides appropriate for use in sandy soils or where extra precautions are needed to reduce the risk of water contamination. You can minimize the risk of point or non-point source contamination by following best management practices, BMPs. BMPs are effective, common sense procedures that emphasize proper mixing, loading, application, and disposal of pesticides. Following BMPs reduces the chance that pesticides will harm the environment. Use integrated pest management principles. Apply pesticides only when and where necessary, and only in amounts adequate to control pests. Use non-chemical control methods whenever possible. When using pesticides, determine the type of pest, the density of the pest problem, and the proper control method. If a pesticide is necessary, choose the least toxic product that will do the job. Calibrate pesticide application equipment regularly. Use spot treatments or band applications if possible to reduce pesticide use. Identify vulnerable areas. The presence of sandy soil, sinkholes, Wells, streams, ponds, and shallow groundwater increases the chance of groundwater contamination. Never dispose of empty pesticide containers in sinkholes, or dump or rinse sprayers into or near sinkholes. Also take care to avoid contaminating drainage ditches and other potential sources of runoff to streams and waterways. Never clean tanks or intentionally discharge water from a tank of any vehicle into a street, along a road, or into a storm drain. Do not mix and load near water. Mix and load as far as possible, at least 50 feet, from wells, lakes, streams, rivers, and storm drains. When possible, do so at the application site. Consider using a sealed permanent or portable mixing and loading pad to prevent seepage into the soil. Keep pesticides away from wells. Do not store or mix pesticides around wells. Poorly constructed or improperly capped or abandoned wells may allow surface water containing pesticides and other contaminants direct entry into the groundwater. Note that wells are sometimes located in or near treated fields and other application sites. Avoid back siphoning. Back siphoning is the reverse flow of liquids into a fill hose. It sucks tank contents, including pesticides, back into the water supply. Back siphoning starts with a reduction in water pressure and can draw very large quantities of pesticide directly into the water source. This happens when the end of the water hose is allowed to extend below the surface of the spray mixture when filling a tank. And you can see here in this image, when you look at B, you can see the fact that the water hose is actually down in the tank water where the mixture is. And that's when we talk about back siphoning being a problem. So if there's a drop in water pressure and you have your hose down in the tank like you see in B, you're going to have a major problem because that water pressure drops. It sucks back in that water with the pesticides and it goes into the water supply. So as we try to avoid back siphoning, the simplest way to prevent backflow is to maintain an air gap between the discharge end of the water supply line and the pesticide solution in the spray tank. An air gap prevents contamination of the hose and keeps pesticides from back siphoning into the water source if a drop or loss of water pressure occurs. Keep the air gap at least twice the diameter of the discharge pipe. Another method to prevent back siphoning is to use a backflow prevention device or check valve. Improved land use and application methods. Terraces and conservation tillage practices can reduce water runoff and soil erosion. Ideally, growers should leave as much plant residue as possible on the soil surface to lessen erosion. Where conservation tillage is not possible, decrease runoff potential by incorporating a low concentration of the pesticide into the soil. In ornamental plantings, consider using mulches to reduce water runoff and soil erosion. Grass buffer strips are very effective in reducing pesticide runoff because they trap sediment containing pesticides and slow runoff water. This allows more runoff water to infiltrate the soil, leaving untreated grass strips next to streams, ponds, and other sensitive areas can trap much of the pesticide running off of these treated areas. Time pesticide applications according to the weather forecast. Pesticides are most susceptible to runoff from heavy rains or irrigation during the first several hours after application. Do not apply to saturated or frozen ground. To avoid overspraying an area and causing drift, check the pesticide label for application precautions or restrictions during windy conditions. Wind speed, temperature, and humidity all affect the off-target movement of pesticides. Select products wisely. Whenever possible, use pesticides that are less likely to leach. Read labels for such warnings. Handle pesticides safely. Follow these guidelines to prevent surface water or groundwater contamination. Immediately contain and control pesticide spills. Check application equipment regularly for leaks or damage. Mix and load pesticides away from water sources. After the pesticide application is complete, follow label directions for proper equipment cleanup and container disposal. After applying granular pesticides, sweep or blow any granules from sidewalks, driveways, or patios onto the treatment area. Whenever possible, clean sprayers at the application site at a safe distance from wells, ponds, streams, and storm drains. Spray the rinse aid onto the treated area or on another site listed on the pesticide label, or use in the next tank mix. Be sure not to exceed label rates. Preventing harmful effects on sensitive areas and non-target organisms. To avoid harming the environment, you must be aware of sensitive areas, non-target plants and animals, especially endangered species, and damaging effects on habitat. Sensitive areas. In addition to water sources, sensitive areas include sites where living things could easily be injured by a pesticide. Outdoor sensitive areas include school grounds, playgrounds, and recreational areas, habitats of endangered species, apiaries, honeybee sites, wildlife refuges, and parks, areas where domestic animals and livestock are kept, ornamental plantings, public gardens, and sensitive food or feed crops. Indoor sensitive areas include places where people live, work, shop, or are cared for, such as hospitals and daycare centers. Food or feed is processed, prepared, stored, or served. Domestic or confined animals live, eat, or are otherwise cared for. Ornamental or other sensitive plants are grown or maintained, such as in malls and buildings. Sometimes pesticides must be deliberately applied to a sensitive area to control a regulated pest, such as mosquito abatement or gypsy moth forest treatments. Only well-trained applicators should perform these applications. At other times, the sensitive area may be part of a larger target site. Whenever possible, take special precautions to avoid treating the sensitive area. Leaving an untreated buffer zone around a sensitive area is a practical way to avoid contaminating it. In still other instances, the sensitive area may be near a site used for mixing and loading, storage and disposal, or equipment washing. Be very careful to avoid contaminating the sensitive area. Check the label for statements that alert you to special restrictions around sensitive areas. Pesticide effects on non-target organisms. Pesticides may affect non-target organisms directly, causing immediate injury, or they may produce long-term consequences through environmental pollution. Pesticides may build up in the bodies of animals or in the soil. For example, if you use the same mixing and loading site or equipment cleaning site over a long period, pesticides are likely to accumulate in the soil. When this occurs, plants and animals that come into contact with the soil may be harmed. The following sections discuss the effect of pesticides on non-target plants, bees, and other beneficial insects, and fish, wildlife, and livestock. Non-target plants. Nearly all pesticides can cause plant injury, phytotoxicity, due to chemical exposure, particularly if applied at too high a rate, at the wrong time, or under unfavorable environmental conditions. Phytotoxicity can occur on any part of a plant, roots, stems, leaves, flowers, or fruits. Most phytotoxic injury is due to herbicides, although damage to crops or other nearby plants is primarily caused by drift. It may sometimes be a consequence of surface runoff and root uptake. Bees and other beneficial insects. Besides making honey and beeswax, bees pollinate many fruit, nut, seed, vegetable, and field crops. You must be aware of bee activity when planning pesticide applications. There has been increasing concern about the decline of bee colonies and the role pesticides may play. Preventing bee loss is the joint responsibility of the applicator, the grower, and the beekeeper. Bees may travel as far as 3 miles from their hive to find blooming flowers. Before applying pesticides labeled as toxic to bees, notify beekeepers in the area so they can protect or move their bee colonies. Some states have laws requiring notification and registries for beekeepers. Bees and other insect pollinators may be exposed to pesticides through different routes, including 1. Direct contact during foliar applications, 2. Contact with residues on plant surfaces after applications, 3. Drip from the application into hive entrance, 4. ingestions of residues in nectar, pollen, or guttation, water, dew, when the pesticide is applied as a seed treatment, soil or tree injection, or foliar application. Insecticides are generally toxic to bees, but some are more hazardous than others. Herbicides are unlikely to harm bees directly. Fungicides do not appear to affect adult bees, but may affect larval development. Tank mixing insecticides and fungicides may create a mixture that is more toxic to bees than either product used alone. Minimize bee kills from insecticide poisoning by following a few basic principles. Pay careful attention to pesticide labels. For each application site, look for the bee hazard icon in the Directions for Use section for specific use restrictions and instructions to protect bees and other pollinators. Do not apply insecticide to crops in bloom. Apply insecticides in the evening or at night when bees are not foraging. Early morning application may protect honeybees, but wild bees forage at or before dawn. Minimize bee kills from insecticide poisoning by following a few basic principles. Do not apply insecticides when weeds or other plants around the treatment site are in bloom. Do not allow the pesticide to drift onto attractive habitat, natural areas, or beehives. Choose the least hazardous insecticide formulation and application method. Pesticides can harm other beneficial insects in addition to bees. These beneficials may be valuable allies in keeping pest populations below damaging levels. A pesticide application often harms the beneficial insect population as much as the target pest. So, do not spray when beneficial insects are in the target area unless it is unavoidable. Alternatively, choose a product that does not harm beneficials. Fish, wildlife, and livestock. Pesticides can harm all kinds of animals. Most injuries occur from the direct effects of acute poisoning. Fish kills often result from water pollution by a pesticide. Insecticides are the most likely cause, especially when small ponds or streams are under conditions of low water flow or volume. Bird kills resulting from pesticide exposure may happen in a number of ways. Birds may ingest pesticide granules, baits, or treated seeds, be exposed directly to sprays, consume treated crops or drink contaminated water, or feed on pesticide-contaminated insects and other prey. Granular or pelleted formulations are a particular concern because birds and other animals often mistake them for food. Liquid formulations may be safer when birds and other wildlife are in or near the treated area. Remove bad dishes from spray areas. Place baits properly so they are inaccessible to pets, birds, and other wildlife. Animals may also be harmed when they eat plants or animals carrying pesticide residues. Predatory birds or mammals feeding on animals killed by pesticides are a special concern. Pesticide residues remaining on or in the bodies of the dead animal may harm predators. This is called secondary poisoning. Check the pesticide label for statements about secondary poisoning. The less obvious effects resulting from long-term exposure to pesticides are a major concern. For example, certain pesticides have been banned because of fish and bird kills and the reproductive failures of several bird species. The most important source of livestock pesticide poisoning has been through contaminated feed, forage, and drinking water. Contamination often occurs as a result of improper or careless transportation, storage, handling, application, or disposal of pesticides. Protecting endangered species. Certain plants and animals have been identified as endangered or threatened species. Be very careful not to harm these populations. Because all living things are part of a complex, delicately balanced network, removing a single species may set off a chain reaction that affects many other species. The full significance of extinction is not always readily apparent, and the long-term effects are often difficult to predict. EPA has a list of endangered species on their website. You should be familiar with those species in your service area. An endangered species is one on the brink of extinction throughout all or a significant part of its range. A threatened species is one likely to become endangered. The reasons for a species decline are usually complex, and thus recovery is difficult. A major problem for most wildlife is the destruction of habitat, usually the result of industrial, agricultural, residential, or recreational development. Each state is responsible for implementing the Federal Endangered Species Protection Program in cooperation with EPA to protect endangered and threatened species from the harmful effects of pesticides. Under this program, pesticide products that might harm an endangered species carry a label statement instructing applicators to consult a county bulletin to determine if they must take any special precautionary measures when using the product. EPA develops these bulletins, which identify precautionary measures required in each county where one or more pesticides could affect an endangered or threatened species. Precautionary measures may include buffer strips, reduced application rates, and timing restrictions, or an applicator might be prohibited from using the pesticide within the identified habitat altogether. Summary: an important part of using pesticides legally and responsibly is considering where the pesticide may end up once it leaves the container and whether it might harm or damage non-target sites, plants, or animals. By applying pesticides at the right time, in the right place, and with the proper application technique, you can greatly reduce or even prevent drift, runoff, and leaching. Pesticides that enter groundwater and surface water are hazardous to aquatic organisms, plants, and wildlife. Therefore, you should implement best management practices to prevent runoff and leaching of pesticides. Sensitive areas include places such as schools, playgrounds, endangered species habitats, and ornamental plantings. Non-target organisms include plants, bees, and other beneficial insects, fish, wildlife, and livestock. Because of the greater risk of injury to people, plants, and animals, you must know when and how to properly apply pesticides in or near such areas. Always check the label statements on endangered and threatened species. You may need to consult a county bulletin that details the procedures for protecting them. It is your responsibility not only to follow label directions, but also to use the best management practices that present the least risk to the environment while achieving effective pest control. You have completed Part 1 of this course. We only have one planet. Please continue to Part 2. Today's course, Advanced Formulations and Combinations, was prepared by Jack Launius. Types of pesticide formulations and mixtures. The most basic pesticide formulations include suspensions and emulsions. As formulations get more advanced, there are several kinds of formulations that are like the basic formulations, but function quite differently. These advanced formulations include capsulated suspensions, microemulsions, water dispersible granules, and many others. Decisions concerning the management and prevention of pest infestations in the urban environment should always be knowledge-based. Integrated Pest Management (IPM) is a decision-making process driven by information collected during an inspection. Pest management professionals, PMPs, committed to an IPM mindset, make decisions about pest management that are logical reactions to the information gathered during the inspection process. An IPM mindset, therefore, demands that all options, including a sensible use of pesticides, be considered when developing a pest management action plan. Decisions. When used responsibly, pesticide-based controls can reduce or eliminate a pest problem while maintaining a stable, sound environment. However, because many pesticides are broad-spectrum, they must be used with great care to prevent undesirable effects. Other considerations are the toxicity, watching the LD50, drift hazards, environmental impact, impact on people and pets, and even impact on beneficial insects such as pollinators. The U.S. Environmental Protection Agency, EPA, defines a pesticide as any substance or mixture of substances intended for preventing, destroying, repelling, or mitigating any pest. Insecticide-based pest control products are composed of a mixture of chemicals classified as either active ingredients or inert ingredients. The specific chemicals in the mixture responsible for affecting the pest organism is referred to as the active ingredient. The active ingredient in its raw form is referred to as technical grade and is often 95 to 100% pure. Although there are a few exceptions, insecticides used by the pest management industry are rarely applied as technical grade active ingredients. Most commonly, the active ingredient is formulated with other chemicals called inert ingredients. While inert ingredients enhance product efficacy and make in-use products easier to use and safer to handle, they have little toxicity towards target pests. Because inert ingredients have great influence on an in-use product's characteristics and properties, especially performance, their identities are often trade secrets not revealed by the product's manufacturer. An active ingredient's chemical name is based on a strict set of internationally adopted rules of nomenclature established by the International Union of Pure and Applied Chemistry, IUPAC, or the CAS Chemical Abstract Systematic Name. These rules are considered the language of chemistry. Embedded within every chemical name are the pieces of information that describe the exact arrangement of every atom and chemical bond in the molecule. Active ingredients are also known by their common name. According to established rules, common names for pesticides are normally issued by the chemical's original manufacturer and then submitted to the International Organization for Standardization (ISO) for approval. Common names reduce confusion caused by multiple trade or brand names discussed below and are less cumbersome than chemical names during oral and written communication. Definitions: active ingredient, the chemical substance responsible for achieving a product's desired effect. Technical grade active ingredient. The chemical substance is pesticide in its raw form, usually 95 to 100% active ingredient prior to being formulated into a product. Definitions: inert ingredient. Inert ingredients are biologically inactive chemicals, i.e., they typically have no pesticidal properties, that are mixed with active ingredients to produce an in-use for sale product. Some commonly used types of inert ingredients and their functions include the following. Emulsifiers allow petroleum-soluble but water-insoluble active ingredients to evenly disperse in water. Dilutants and carriers are meant to dilute the amount of active ingredient in a formulation described later to carry it to its intended target. Often the same material serves as both dilutant and carrier. For example, talc is an inert ingredient in many dust formulations. Definitions: only a small part of the dust formulation is insecticidal. The remainder is inert talc that not only dilutes the active ingredient, but also carries it to its intended target. In liquid spray formulations, water is both a dilutant and carrier. In granular formulations, the inert granule on which the pesticide is absorbed is the carrier. Definitions: stickers allow active ingredients to stick or adhere to the treated surface. Wetting agents, e.g., spreaders, dispersants, penetrants, are inert chemicals that are added to water to increase spreading and/or penetration by eliminating or reducing surface tension. For example, a drop of water will bead on wax paper, but when a spreader/dispersant is added, the water droplet spreads evenly over the wax paper. Wetting agents are used in wettable powder formulations to allow the powder to evenly mix with water. Definitions: solutions are liquids, and all the chemicals that are dissolved in the liquid, for example boron, dissolve completely when placed in water to make a solution. In this example, water is called the solvent and the boron is called the solute. When a chemical is soluble in a liquid, it forms a solution and cannot separate. Definitions: a suspension is a liquid that contains solid particles that are not dissolved. Over time, the solid particles will settle to the bottom of the container. Many liquid spray formulations, wettable powders, suspendable concentrates, and microencapsulates are suspensions in water, and will settle to the bottom of the sprayer if not agitated. Suspensions should be shaken or agitated often to resuspend the product in the water. Definitions: contact toxicants are chemicals that penetrate the target organism on contact. For example, liquid sprays are usually effective only after an insect crawls on the treated surface and contacts the residual deposit. Oral toxicants are chemicals that act after having been ingested by the target organism. For example, bait products kill only after an insect consumes the bait containing the active ingredient. Fumigants are chemical gases. They act after an insect breathes them. The product label. Most pesticide products used by the pest management industry must be registered with and granted a label by the EPA. A product label is a manufacturer's written directions on how to use and not use the product and is based on extensive testing, specific knowledge, supportive data, and product experience. To be granted a label, a product manufacturer must provide the EPA supportive data as well as other documentation to convince the EPA that the product may be used without unreasonable risk to non-target organisms or the environment. Additionally, supportive data is required to be submitted to the EPA for pesticides labeled for control of some structural and public health pests. Efficacy data must support label claims for control of these pests when used according to label instructions. The product label. Labels are specific about how a product can and cannot be used. Because the label is a legal document, it is a requirement that pesticide users comply with the directions for use on the label. Users should always heed a manufacturer's recommendations and mandates and never do more than what is permitted by a product's label. Use of a product in a manner that is not permitted by the label is a violation of federal law and can carry state and/or federally imposed penalties. All EPA-granted labels contain the statement, "It is a violation of federal law to use this product in a manner inconsistent with its labeling." In other words, the label is the law. The product label. It is very important that PMPs be familiar with the product's label, not to only ensure that the product is being used in the most efficacious manner possible, but to ensure that its use is safe, legal, and environmentally responsible. The product label. Important information on a product's label includes first aid measures, in the case of an accidental poisoning, including emergency phone numbers, precautions when mixing, handling, applying, and storing the product, including the use of personal protective equipment, recommendations for disposal of used containers and contaminated rinse water or wash water, and potential hazards that can result from the misuse of the product. For example, the product's impact on various non-target organisms, such as fish, bees, and other wildlife. The product label. The majority of a product's label is directions for use. The directions for use section commonly includes pests that can be treated with the product, where the product can and cannot be used, and how to mix the product to achieve the desired concentration. The directions for use section also provides information on product concentrations, application volumes, and suggestions on how spot, general spray, crack and crevice, and where, specific sites, to apply the product to best achieve control of the pest listed. SDS Safety Data Sheet. The Hazard Communication Statement HCS 29 CFR 1910.1200G, revised in 2012, requires that the chemical manufacturer, distributor, or importer provide safety data sheet SDSs, formerly MSDS or material safety data sheets, for each hazardous chemical to downstream users to communicate information on these hazards. The information contained in the SDS is largely the same as the MSDS, except now the SDS are required to be presented in a consistent, user-friendly 16-section format. This brief provides guidance to help workers who handle hazardous chemicals to become familiar with the format and understand the contents of the SDSs. SDS Safety Data Sheet. The SDS includes information such as the properties of each chemical, the physical, health, and environmental health hazards, protective measures, and safety precautions for handling, storing, and transporting the chemical. The information contained in the SDS must be in English, although it may be in other languages as well. In addition, OSHA requires that the SDS preparers provide specific minimum information as detailed in Appendix D of 29 CFR 1910.1200. The SDS preparers may also include additional information in various sections. SDS Safety Data Sheet. Sections 1 through 8 contain general information about the chemical identification, hazards, composition, safe handling practices, and emergency control measures, e.g. firefighting. This information should be helpful to those that need to get the information quickly. Sections 9 through 11 and 16 contain other technical and scientific information, such as physical and chemical properties, stability and reactivity information, toxicological information, exposure control information, and other information including the data preparation or last revision. Let's talk about signal words. Signal words that may appear on the label. When we look at our chart, you can see in the upper left-hand side, we see signal word. Looking just below, we're going to start with danger or danger poison. The category for that product would be Class 1, highly toxic, and the toxicity lethal dose would be corrosive or irritant properties, a few drops to 1 teaspoon. Looking at our second signal word in orange, which would be warning, the category would be a Class 2, moderately toxic, and its toxicity lethal dose would be 1 teaspoon to 1 ounce. Looking at our third signal word in yellow, it's going to be caution. Its category is Class 3, slightly toxic, and its toxicity lethal dose is going to be 1 ounce to 1 pint or 1 pound. Looking at our final signal word in green, we're going to have caution or none. The category is going to be Class 4, very slight hazard. Toxicity lethal dose is going to be over 1 pint or 1 pound. Lethal doses are listed for a 150-pound adult. A product's toxicity category determines what must be on its label. Let's take a look at the acute toxicity categories for pesticide products hazard indicators. As you can see, we've got 4 columns on this chart. First, we have in red, highly toxic category 1, danger/danger poison. In category 2, we've got moderately toxic, category 2 warning. We got category 3 in column 3 in blue, which is going to be low toxicity, category 3 caution. And our final category in green is going to be very low toxicity, category 4, optional signal word caution. Looking back on the left side of our screen, you can see we're starting by looking at an oral LD50. So let's look at it. Oral LD50 under column 1, highly toxic, category 1, danger/danger poison, is up to and including 50 milligrams/kilograms. When we look at oral LD50 under category 2, which is going to be moderately toxic, category 2 warning, it's going to be greater than 50 through 500 milligrams/kilograms. If we look at oral LD50 under column 3, low toxicity, category 3 caution, it's going to be greater than 500 through 5,000 milligrams/kilograms. And looking again at oral LD50 under category 4 in green, optional signal word caution, it's going to be greater than 5,000 milligrams/kilograms. Let's take a look again at the left column on our chart. Let's go down to dermal LD50. When we talk about dermal LD50 and we look at it under column 1, highly toxic, category 1, danger/danger poison, we see it's up to and including 200 milligrams/kilograms. If we look at dermal LD50 under moderately toxic, category 2 warning, it's going to be greater than 200 through 2,000 milligrams/kilograms. If we look at dermal LD50 under category 3, low toxicity, category 3 caution, we're going to be greater than 2,000 through 20,000 milligrams/kilograms. And if we look at dermal LD50 under very low toxicity, category 4, optional signal word caution, it's going to be greater than 20,000 milligrams/kilograms. Looking further down on our chart of acute toxicity categories for pesticide products hazard indicators, you're going to see inhalation LC50. If we look at this under the column highly toxic category 1 danger/danger poison, you can see it's up to and including 0.2 milligrams/liter. If we look under category 2 moderately toxic category 2 warning, you can see it's greater than 0.2 through 2 milligrams/liters. If we look under category 3 low toxicity category 3 caution, you can see it's greater than 2 through 20 milligrams/liters. And if we look at our final column, very low toxicity category 4 optional signal word caution, you can see it's greater than 2.0 milligrams/liters. Looking further down the left side of our chart, you can see we're going to look at eye irritation. Eye irritation under the highly toxic category 1 danger/danger poison is considered corrosive, corneal opacity, not reversible within 7 days. If we look at it under moderately toxic category 2 warning, eye irritation, corneal opacity reversible within 7 days, irritation persisting for 7 days. If we look at eye irritation under the column low toxicity category 3 caution, no corneal opacity, irritation reversible within 7 days. And if we look at eye irritation under our final column, very low toxicity category 4 optional signal word caution, there's going to be no irritation. Looking at the bottom of the column on the left hand side of our chart, you're going to see skin irritation. When we look at skin irritation under highly toxic category 1 danger/danger poison, you can see it's corrosive. If we look at skin irritation under column 2 moderately toxic category 2 warning, you can see it says severe irritation at 72 hours. If we look at skin irritation under low toxicity category 3 caution, you can see it can cause moderate irritation at 72 hours. And we would look at skin irritation in our last column, very low toxicity category 4 optional signal word caution, it's going to be mild or slight irritation at 72 hours. Active ingredient. Adjuvants enhance pesticide efficacy without increasing the toxicity or increasing the effectiveness of a specific mode of action. Types of pesticide formulations and mixtures. Many products used in conjunction with others will add to the overall level of control. Spraying alone isn't enough. Types of pesticide formulations and mixtures. Solubles. Soluble products form a true dilution when the active ingredient is dissolved completely into water. Boron. One of the most common soluble products used for general pest and termite control. Types of pesticide formulations and mixtures. The most common soluble pesticide used today is boron. Boron can be purchased under several trade names. Timbor, Nibor, and Bor Defense are a few examples. Boron, in the soluble form, is used generally for wood-destroying organisms. Types of pesticide formulations and mixtures. When applied on wood, it penetrates the cellular structure of the wood, making the wood toxic to termites. In a dry form, it can be used for ants and cockroaches. It absorbs small amounts of water out of the air and is sweet tasting. Wettable powders and suspensions. These carrier agents want to settle and require frequent agitation to continue floating in the product. A huge advantage of products carried in a suspension is that they do not burn plants like many emulsions do. They also sit on the surface of porous materials, allowing more contact with the pest. Once the product is dry, it doesn't move through the soil, it stays in place until no longer active. Wettable powder. Wettable powder formulations are created by impregnating or coating a microscopic particle of an inert carrier, e.g., absorptive clay, talc, etc., with insecticide and various inert ingredients to enhance the wetting, spreading, and dispersing characteristics of the powder. The inert ingredients, wetting agents, allow the dry powder to evenly disperse in and mix with the water without clumping or caking. Because wettable powders are true suspensions, constant agitation is required to keep the powder suspended in water. Wettable powders do not readily absorb into skin, but care should be taken when using this formulation to avoid accidental inhalation. Wettable powders and suspensions. These carrier agents want to settle and require frequent agitation to continue floating in the product. A huge advantage of products carried in a suspension is that they don't burn plants like many emulsions do. Once the product is dry, it doesn't move through the soil, it stays in place until no longer active. Emulsions. Emulsions are formed when an emulsifier is used to combine two parts of a finished solution or product that otherwise wouldn't mix. Generally, active ingredients are mixed in an oil base. Oil and water do not mix. Therefore, an emulsifier is required for the active ingredient to float evenly in the finished solution. Emulsifiables. Water and oil do not mix unless an emulsifying agent is added. When an emulsifier is added to a mixture of oil and water, microscopic droplets of oil are formed that disperse throughout the water. The resultant milky white mixture is referred to as an emulsion. The droplets in emulsifiable formulations do require minimal agitation in comparison to formulations that are suspensions, wettable powders, microencapsulates, suspension concentrates that may require more agitation. Emulsions. Emulsions require frequent agitation, otherwise the active ingredient will settle to the bottom of the mixture. This is typical because the pesticide never completely dissolves. Emulsions. Because of the oil base, emulsions are more readily absorbed through the insect cuticles, making them more likely to kill on contact. Oils in this product also cause faster skin absorption in humans, and therefore applicators should be especially careful about getting it on their skin and on non-target organisms. Zenprox EC. The EC in the product name signifies that the product is an emulsifiable concentrate. Zenprox EC contains an ether pyrethroid that bonds differently to the nerve cell than other pyrethroids. Because of its unique mode of action and formulation, it is less likely to cause insect resistance and is very effective for interior treatments. Because it is held in an emulsion, it penetrates the insect cuticle faster and has a faster knockdown. Next, we're going to take a look at microemulsions. Microemulsions. Acetemprid, the first active ingredient, has a high rate of lateral transfer, which is enhanced by the small particle size. The second active ingredient, bifenthrin, leaves a long residual. Microemulsions. The small particles make it likely to penetrate the insect cuticle and soil surface even faster than other emulsions. A microemulsion particle is 100 times smaller than a particle from a standard emulsion and 1,000 times smaller than a microcap. Microencapsulated are formed by encapsulating an insecticide in a microscopic, round plastic capsule. The capsules are mixed with inert ingredients, dispersants, wetting agents, etc., to keep them from clumping and to help the mixture flow more readily. The inert ingredients also facilitate storage and dispersion when diluted in water. Microencapsulated. The capsule's wall thickness determines the release rate of the insecticide to the outside environment. The insecticide seeps through the capsule's wall and coats the outside of the capsule. As the insecticide disappears, degradation, evaporation, etc., additional insecticide inside the capsule continues to coat the capsule surface. This process maintains a capsule that is constantly coated with a thin film of insecticide. Microemulsions. Transport Micron is well suited for smaller insects like soakids due to its small particle size, absorption rate, and dual mode of action. The product does not contain label restrictions beyond what is normally found with regards to neonicotinoids and even pyrethroids. Microencapsulated suspensions. The acronym CS implies that a product is a capsulated suspension. Small capsules are evenly divided in the carrier agent, water. These microcaps are relatively small and are about 30 microns in size. Because the microcaps break down slowly, the products tend to leave behind a good residual, but are generally slow-acting. Microencapsulated suspensions. The residual benefits of these products are enhanced by the fact that the active ingredients are protected from the elements, harsh weather, UV rays, and the high pH levels found on brick and concrete. Some products can have as many as 10,000 microcaps per square inch. Onslaught Fast Cap is a pyrethroid-based polymeric microencapsulation. It has 3 active ingredients. The first 2 are pyrethroids, and the third is Synergist that enhances the effectiveness of the product. This is a typical product not only because it has 2 pyrethroids in it, but also because modern pyrethroids don't generally come with a Synergist. Onslaught Fast Cap. The Synergist PBO enhances pyrethroids specifically and makes this product one of the strongest pesticides for spiders and scorpions. The Synergist also helps to make the product fast-acting, unlike some other microencapsulated products, but the product retains its long residual due to the formulation. This product is highly repellent and consideration should be taken when applying since it can create new problems with ants, cockroaches, and other highly unpredictable pests. Water dispersible granules. Airlon is an example of a product held in water dispersible granules. Despite containing minerals, Airlon has not been shown to stain any surfaces. The granules are evenly suspended in water after mixing and disperse evenly on surfaces when applied. The active ingredient in Airlon, indoxacarb, has been shown to have exponential control since the product has a high rate of lateral transfer. Water dispersible granules. The product is target specific and through its meta-active activation, it can differentiate between target pests and non-target organisms. It works great on cockroaches but terrible on bees. Water dispersible granules. When it is inside of an insect, it combines with enzymes and forms the meta-active compound. As an example, the meta-active compound can often be found in the sputum of cockroaches several generations after the first cockroach is fed. Synergist. Exciter is a common product containing a synergist and is mixed with other products to synergize them. Exciter does not leave a residual treatment on surfaces, instead it has a rate of contact mortality. The combination of Exciter with residual products has the knockdown that is common with Exciter and the residual of the other product. Synergist. Synergists are products or active ingredients that enhance the toxic effect of a specific pesticide or active ingredient. The most common synergist is piperonyl butoxide PBO. Generally, PBO is used to enhance the mode of action found in pyrethrins and pyrethroids. PPO blocks the mode of action found in sodium channel inhibitors by blocking an insect's natural defense to these products. Surfactants. Surfactants are a type of adjuvant that add to the efficacy of a pesticide without adding to the toxicity level or enhancing the effect of a specific mode of action. Surfactants enhance the ability of water molecules to naturally bond together, which creates a more uniform distribution of a spray mixture on plant leaves and on ground surfaces. Surfactants are also wetting agents. This means that they allow water and products to more easily penetrate soil. Surfactants. Adding surfactants to products in a suspension will force them to penetrate soil that they otherwise might not. Surfactants also force products that tend to penetrate the soil to move deeper. Yucca is a surfactant made from the Yucca scitigera plant found in the desert. The Yucca scitigera plant produces its own chemical compounds to help it manage water more effectively. It is perfect for use with any pesticide or fertilizer, and when used by itself can enhance the vitality of plants and even correct some soil conditions. Baits. Baits enhance treatments by adding to the effectiveness of spray treatments. Granular baits can be put into gardens and yards. Boron-based baits such as Niban and Mother Earth G last longer than the average spray application and can extend the effective life of a pest control treatment since they will remain active once the liquid application has lost its residual action. When looking at Niban granular bait, the active ingredient is orthoboric acid 5%. Other ingredients are 95% for a total of 100%. Baits. Bifenthrin in a suspension will last up to 30 days, max Thor, according to the manufacturer. Boron-based baits such as Niban last beyond 1 month and continue to work as they break down. Abamectin-based baits such as Advance 375A have been shown to limit reproduction of ants. They should be used in spring when reproduction is at its highest levels and can accompany boron-based baits or be used as a sole bait on a property. Let's take a look at some specific pesticides and their formulations. Let's start with Aerolon. That would be water-soluble granules. Onslaught Fast Cap, microencapsulated suspension. Optigard Flex, microencapsulated suspension. Maxthor SC, suspension concentrate. Microcare 3% CS, microencapsulate suspension. Premise 2, suspension concentrate. Premise 75WP, wettable powder suspension. Prothor SC2, suspension concentrate. Suspend SC, suspension concentrate. Temperate SC, suspension concentrate. Tempo SC Ultra, suspension concentrate. Tempo Ultra WP, wettable powder suspension. Transport Micron, microemulsion. Zenprox EC, emulsion. Let's first take a look at Aerolon, which is a water-soluble granule. Aerolon. Aerolon is an insecticide that can be used to control a broad range of pests. The active ingredient is indoxacarb 20%. Uses non-repellency with slight delay in mortality, which allows target insects to carry it back to their site and share it with other insects for thorough control. Aerolon is a non-pyrethroid designed for flexible use indoors as a 10-foot band application outdoors. It can also be used as a crack and crevice application in food handling establishments as directed by the product label. Insects on the Aerolon label: ants, beetles, box elder, carpenter bees, centipedes, cockroaches, crickets, earwigs, fleas, flies, grasshoppers, millipedes, pillbugs, silverfish, sowbugs, springtails, stink bugs, and wasps. Onslaught Fast Cap. Onslaught Fast Cap spider and scorpion insecticide has a unique formulation that contains exponent synergist that enhances two other active ingredients, esfenvalerate and perlethrin. This quick-acting insecticide may be used indoors and outdoors on homes and has a label for food and non-food areas in commercial structures. Onslaught Fast Cap is labeled for indoor, in food and non-food areas. Onslaught Fast Cap may be used in homes, food processing plants, restaurants, schools, warehouses, hotels, outdoor perimeter treatments to areas such as around garbage cans, porches, patios, carports, garages, fence lines on trees, lawns, landscapes, and turf in and around livestock housing. Onslaught Fast Cap has a quick-acting microencapsulated formula, gives a quick kill while still providing a residual control. Insects included on the Onslaught Fast Cap label include ants, Asian lady beetles, bed bugs, box elder bugs, carpenter ants, cockroaches, confused flower beetles, darkling beetles, lesser mealworm, face flies, fleas, fruit flies, horn flies, hornets, house flies, Indian meal moths, lesser grain borers, mosquitoes, red flower beetles, rice weevils, sawtooth grain beetles, scorpions, small flying moths, spiders, stink bugs, swarming termites, ticks, wasps, and yellow jackets. Onslaught Fast Cap. Mix Onslaught Fast Cap with an IGR such as Nigard IGR concentrate to break the insect growth cycle and control future emerging insect populations as part of an IPM program. Optigard Flex. Active ingredient, thiamethoxam, CAS number 153719-23-4, 21.6%. Other ingredients 78.4% for a total of 100%. Optigard Flex Liquid is a suspension concentrate formulation that contains 2 pounds thiamethoxam per gallon formulated product, 244 grams thiamethoxam per liter formulated product. Optigard Flex for control of listed pests including cockroaches, ants, except carpenter ants and pharaoh ants, fire ants and beetles, for control of localized infestations of drywood termites, subterranean termites, carpenter bees, and wood-destroying beetles and borers. Maxthor SC suspension concentrate, made by Insistex, is labeled for an extremely broad usage both indoors and outdoors and cover a wide variety of pests. Its goal is to have a strong stability and a long residual on almost any type of surface. The active ingredients in Max Thor SC is bifenthrin 7.9%, other ingredients are going to be 92.1%, and total ingredients are going to be 100%. Max Thor SC is effective on a wide variety of pests due to its active ingredient of bifenthrin. Microcare 3% CS. Microcare 3% CS control release insecticide is designed to save you time by staying in water solution without agitation. This botanical insecticide delivers fast knockdown and residual control of a broad spectrum of pests. Microcare 3% CS kills accessible stages of angoumois, grain moths, ants, excluding harvester ants, Asian lady beetles, bees, box elder bugs, cadelles, carpet beetles, carpenter ants, carpenter bees, centipedes, cigarette beetles, clover mites, cockroaches, confused flower beetles, crickets, dermestid beetles, dried fruit beetles, drugstore beetles, fire brats, fleas, flies, fungus gnat larvae, gnats, grain mites, India meal moths, mealworms, mealybugs, Mediterranean flower moths, millipedes, mosquitoes, moths, red flower beetles, sawtooth grain beetles, scorpions, silverfish, sowbugs, spiders, ticks, Tragoderma, wasps, weevils, granary and rice weevils, and yellow jackets. Microcare 3% CS for use in and around bakeries, beverage plants, calf hutches, canneries, dairies, flour mills, federally inspected meat and poultry plants, food handling establishments, food processing plants, food storage areas, grain elevators, grain mills, granaries, hog operations, homes, horse barns, hospitals and nursing homes, except patient rooms while occupied, hotels, industrial installations, kennels, landscapes, loafing sheds, meat packing plants, milk rooms, milking parlors, motels, office buildings, poultry operations, residences, restaurants, schools, stables, supermarkets, transportation equipment, airplanes, cargo areas only, boats, buses, rail cars, ships, trailers and trucks, warehouses and zoos. Let's take a look at Premise 2 insecticide, which is a suspension concentrate. Premise 2. For use by individuals, firms licensed or registered by the state to apply termiticide products. States may have more restrictive requirements regarding qualifications of persons using this product. Contact the Structural Pest Control Regulatory Agency of your state prior to use of this product. For prevention or control of subterranean termites, drywood termites, dampwood termites, carpenter ants, and other wood-infesting insects. Premise 2. Premise 2 has an active ingredient of imidacloprid, 1-6-chloro-3, pyridinyl, methyl, N-nitro-2, imidazolidininamine, 21.4%, with inert ingredients of 78.6%. It contains 2 pounds of imidacloprid per gallon. Premise 75WP. Premise 75WP is a wettable powder termiticide that was formulated to provide professional, lasting, and effective termite control. Premise 75WP may be used to do a soil-based perimeter treatment around a home's foundation to prevent termite infestation or treating localized areas of known subterranean termite activity. Premise 75WP. Premise was formulated for controlling drywood and dampwood termites, borers, and other wood-infesting insects in and around basements, attics, crawl spaces, voids, and damaged wood piles. Premise is a non-repellent termiticide, meaning that termites do not detect that Premise is present. Premise was designed for termites to contact the product, then transfer it to other termites, eventually killing the colony. The next product we're going to take a look at is ProThor SC2, which is a suspension concentrate. ProThor SC2. for prevention or control of subterranean termites in and around residential, commercial, industrial, institutional, and public structures and buildings, for foliar and systemic control of insect pests of turf grass, landscape ornamentals, shrubs and trees in lawns, golf courses, landscapes, playgrounds, parks, athletic fields, and interior plantscapes. Prothor SC2. Active ingredient is going to be imidacloprid, 21.4%. Other ingredients are going to be 78.6%, and it contains 2 pounds of imidacloprid per gallon. Our next product is going to be Suspend SC, which is a suspension concentrate insecticide. Suspend SC, only for use in storage by pest control operators and/or commercial applicators for residential, industrial, and institutional control of major nuisance pests listed on the label. Controls numerous pests in and around households and other structures, will not damage paints, plastics, fabrics, or other surfaces where water alone causes no damage. For insect control on commercial and residential turf and landscape ornamental plants. Suspend SC active ingredient is going to be deltamethrin, 4.75%. Other ingredients are going to be 95.25%, and it contains 0.42 pound deltamethrin per gallon. Suspend SC. Listed insects on the label are going to include ants, carpet beetles, firebrats, fleas, gnats, midges, centipedes, millipedes, pantry pests, silverfish, ticks indoors. Suspend SC is also labeled for bees, bed bugs, box elder bugs, fleas outdoors, cessid flies, cockroaches, crickets, flies, including such flies as stable, house, cluster, and horse flies, elm leaf beetles, ground beetles, moths, midges, hornets, killer bees, lice, mosquitoes, multicolored Asian lady beetle, pillbugs, scorpions, sowbugs, spiders, yellow jackets, wasp, and carpenter ants. Temperate SC. Temperate SC is a suspended concentrate insecticide that offers a dual mode of action by using 2 powerful and effective residual insecticides, beta-cyfluthrin and imidacloprid. The result is a dual action product. Temperate SC is labeled for indoor and outdoor use. Temperate SC. In the state of New York, this product may only be applied for indoor uses. Active ingredient is going to be imidacloprid, 1-6-chloro-3-pyridinil, methyl N-nitro-2-imidazolidinamine, 21%, B-cyfluthrin, cyano-4-fluoro-3, phenoxyphenyl, methyl 3-2-2-dichloroethanol, 2,2-dimethyl, cyclopropane carboxylate, 10.5%. Other ingredients are going to be 68.5%. Temperate SC. The labeled insects are going to include ants, bed bugs, blue or green bottle flies, box elder bugs, brown marmorated stink bugs, carpet beetles, centipedes, clothes moths, clover mites, cluster fly, cockroaches, crickets, darkling beetles, dermestids, earwigs, elm leaf beetles, firebrats, flesh flies, flies, fruit flies, gnats, hide beetles, hornets, houseflies, kudzu, globular stink bugs, leather beetles, midges, millipedes, moths, multicolored Asian lady beetles, forward flies, pillbugs, cyarid flies, fungus gnats, silverfish, sowbugs, spiders, wasp, and yellow jackets. Let's take a look at our next suspension concentrate, Tempo SC Ultra. Tempo SC Ultra, cyfluthrin cyano 11.8%, was designed to be an effective broad-spectrum spray for both indoor and outdoor applications, including trees, lawns, shrubs, etc., designed for a quick knockdown and residual control. Our next product is going to be Tempo SC Ultra, which is a suspension concentrate. Active ingredient is going to be B-cyfluthrin cyano 4-fluoro, phenoxyphenyl methyl 3-2,2-dichloroethanol, 2,2-dimethyl, cyclopropane carboxylate, 11.8%. Other ingredients, 88.2%. Contains 1 pound cyano 4-fluoro 3-phenoxyphenyl methyl 3-2,2-dichloroethyl 2,2-dimethyl cyclopropane carboxylate per gallon. Insects controlled on the Tempo SC Ultra label include ants, except Pharaoh and Harvester, fire ants, aphids, armyworms, azalea caterpillars, bagworms, beetles, billbugs adult, black turfgrass Atenius adult, black vine weevil adult, blowflies, bluegrass billbug adult, box elder bugs, bristly rose slugs, budworms, cadelles, beetles, California oakworms, cankerworms, case bears, carpenter ants, carpenter beetles, caterpillars. Continuing our insects controlled list with Tempo SC Ultra, we have chiggers, chinch bugs, cigarette beetles, clothes moths, clover mites, cockroaches, confused flower beetles, crickets, cutworms, darkling beetles, dermestid beetles, drugstore beetles, earwigs, elm leaf beetles, elm spanworms, field flies, firebrats, flea beetles, flies, flower four beetles, fruit flies, fungus gnats, grain mites, granary weevil, grasshoppers, ground beetles, gypsy moth larvae, hide beetles, hornets, houseflies, hyperodes weevil adult, Indian meal moths, Japanese beetles adult, June beetles adult, lace bugs, larder beetles, leaf-eating caterpillars, leaf hoppers, leaf rollers. Closing out the list of insects controlled on the Tempo SC Ultra label, we have leaf skeletonizers, leather beetles, lesser grain borers beetles, lesser mealworms, mealybugs, Mediterranean flower moths, merchant grain beetles, mealworms, mealworm beetles, millipedes, mole crickets, mosquitoes, moths, oleander moth larvae, orchid weevil, pear, scilla, pepper tree psyllid, board flies, pill bugs, pine shoot moths, pine tip moths, plant bugs, red flower beetles, red humped caterpillars, rice weevils beetles, sawfly larvae, sawtooth grain beetles, scale insect, crawler stages, cyarid flies, silverfish, sod webworms, sow bugs, spider mites, spiders, spittle bugs, stable flies, striped beetles, striped oakworms, tent caterpillars, thrips, ticks, tussock moth larvae, walnut caterpillars, warehouse beetles, webworms, whiteflies, yellow jackets, yellowneck caterpillars direct spray only. The next product we're going to look at is Transport Micron, which is a microemulsion. Transport Micron to control termites and listed household pests indoors and around the exterior perimeter of residential, institutional, public, commercial, industrial buildings, and non-commercial barns, i.e., non-commercial barns are storage structures not intended for housing livestock and other pests, and food feed handling establishments. Transport Micron active ingredient azathioprine 5%, bifenthrin 6%. Other ingredients are going to be 89%. Insects on the Transport Micron label include ants, including red imported fire ants, carpenter ants, and Argentine ants, but excluding Pharaoh ants, bees, beetles, not for use in California, biting flies, box elder bugs, carpenter bees, centipedes, chiggers, clover mites, cockroaches, crickets, earwigs, elm leaf beetles, firebrats, fleas, flies, gnats, ground nesting solitary bees and wasps, midges, millipedes, mosquitoes, moths, pillbugs, scorpions, silverfish, sowbugs, spider mites, spiders including black widow, springtails, stink bugs, ticks including brown dog ticks, and wasps. The next product we're going to take a look at is Zenprox EC, which is an emulsion or emulsifiable concentrate. Zenprox EC kills ants, bedbugs, cockroaches, centipedes, crickets, flies, fleas, fruit flies, gnats, mosquitoes, moths, scorpions, silverfish, spiders, brown recluse, black widows and others, ticks, wasps, and other listed insect pests. It's for use in homes, apartments, hotels, schools, nursing homes, hospitals, office buildings, warehouses, commercial and industrial buildings, and other listed buildings and structures. Zenprox EC. The active ingredients are going to be Edofenprox CAS number 80844-07-1, 16.2%, Piperonil butoxide CAS number 51-03-6, 64.8%. Other ingredients are going to be 19%. Butylcarbidyl 6-propylpiperonil, ether, and related compounds. This formulation contains 1.4 pounds Edofenprox and 5.6 pounds of piperonil butoxide per gallon. In-use dilution is 0.25% Edofenprox. We have to ask the question, why are formulations so important? Formulations are one of the biggest decisions you make when performing a pest control service. You need to consider the pests being treated, the metamorphosis, their social behavior, and other factors. And this is very important. If we don't understand these types of things, we're never going to solve the problem. Obviously, you need to identify the pest. Look at the metamorphosis. Look how they grow. Think about the different life cycles and understand what the best products will be depending on the different stages of the life cycle. Also, in some life cycles, you may not even be able to kill them. These are things you need to think about, as well as their social behavior. You need to understand if it's a colonizing insect like an ant, we're going to treat it differently than we would millipedes or something like that. So we're really just hitting the tip of the iceberg on the importance of formulations, but I at least want you thinking and getting some ideas of what you need to do when you're choosing a formulation. Sensitivity of accounts. Another factor is going to be the sensitivity of accounts. You would think differently when treating a daycare center than a home with no children or pets. Always think about where you are treating, who it will affect, and what is around you before you select the product formulation. We're using daycare center as an example here because, as you can imagine, with children crawling all over the floor inside of a building, how comfortable would you be using pesticides in an area like that? Also, if you do need to use pesticides indoors, where are you going to put them? You really need to think about that because now we've got an issue of keeping the pesticides out of reach of children, making sure they don't come into contact with them. So maybe more of an exterior application makes more sense, but then we've got the issue that kids might even be outdoors. So you really need to think about something like a daycare center totally differently than you would a home with no children or pets, where you really don't have the same level of worry about exposure in an area like that. Commercial accounts. Consider office buildings. You may be dealing with many different personalities when treating a large structure. Does it make sense to go in and hose down the baseboards in offices? Many times, applicators do things like this, and companies must wind up explaining their way out of a bad situation. And I'm speaking to this from experience. I've had technicians that were under my charge that did this and told people to lift their feet up, whatever the case was. People told me they didn't even want their offices sprayed. This was in the older days, but I can tell you there's still companies that go out and do things like this. So really think about commercial accounts, especially when you're coming into contact with a lot of different people, because there can be several different issues and you're going to be dealing with personalities that can have a wide range of thoughts about pesticide use in general. What about schools and public buildings? These types of accounts can have an even higher level of concern. As you can imagine, you must understand the sensitive nature of them. You must also read and understand any state laws pertaining to pest treatments in these types of structures. It is very common to have specific guidelines set by the state that must be followed when treating these types of buildings.
You have completed Part 2, Advanced Formulations and Combinations. Please continue to Part 3.
Insects and their relatives. This course covers insects development. These changes is called metamorphosis. The kind of changes may vary among different insect groups. Metamorphosis can be no metamorphosis, gradual metamorphosis, incomplete metamorphosis, complete metamorphosis. Pests covered are arachnids, crustaceans, centipedes, and millipedes, flies, ants, and cockroaches. Insects and their relatives. Insects, physical characteristics. All insects in the adult stage have two physical characteristics in common. They have three pairs of jointed legs, and they have three body regions: the head, the thorax, and abdomen. The head supports antennae, eyes, and mouth parts. The antennae vary in size and shape and can be a help in identifying some pest insects. Insects have compound eyes made up of many individual eyes. These compound eyes enable insects to discern motion, but probably not clear images. The four general types of mouth parts are chewing, piercing sucking, sponging, and siphoning. With insects and their relatives, chewing mouth parts contain toothed jaws that bite and tear the food. Cockroaches, ants, beetles, caterpillars, and grasshoppers are in this group. Piercing sucking mouth parts consist of a long, slender tube which is forced into plant or animal tissue to suck out fluids or blood. Insects with these mouth parts are stable flies, sucking lice, bed bugs, mosquitoes, true bugs, and aphids. With insects and their relatives, sponging mouth parts have a tubular tongue-like structure with a spongy tip to suck up liquids or soluble food. This type of mouth part is found in the flesh flies, blowflies, and houseflies. Siphoning mouth parts are formed into a long tube for sucking nectar. Butterflies and moths have this type. When looking at insects, we need to talk about metamorphosis. This is the series of changes through which an insect passes in its growth from egg to adult and is called metamorphosis. When the young first hatches from an egg, it is either a larva, nymph, or naiad. After feeding for a time, the young grows to a point where the skin cannot stretch further. The young molts and new skin is formed. The number of these stages, called instars, varies with different insect species and in some cases may vary with temperature, humidity, and availability in kinds of food. The heaviest feeding generally occurs during the final two instars. Some insects do not change except in size between hatching and reaching the adult stage. The insect grows larger with each successive instar until it reaches maturity. Examples are silverfish, firebrats, and springtails. The food and habits of the young, called nymphs, are similar to those of the adult. When looking at gradual metamorphosis, insects in this group pass through three quite different stages of development before reaching maturity. This is going to be the egg, the nymph, and the adult. The nymphs resemble the adult in form, eat the same food, and live in the same environment. The change of the body is gradual, and the wings, when present, become fully developed only in the adult stage. Examples of this are cockroaches, lice, termites, aphids, and scales. The insects with incomplete metamorphosis also pass through three stages of development: egg, naiad, and adult. The adult is similar to the young, but the naiads are aquatic. Examples of these insects are going to be dragonflies, mayflies, and stoneflies. The insects with complete metamorphosis pass through four stages of development: egg, larva, pupa, and adult. The young, which may be called larvae, caterpillars, maggots, or grubs, are entirely different from the adults. They usually live in different situations and in many cases feed on different foods than adults. Examples of this are going to be beetles, butterflies, flies, mosquitoes, fleas, bees, and ants. Let's look at some insect-like pests. We're going to have in this category mites, ticks, spiders, sow-bugs, pill-bugs, centipedes, and millipedes, and they resemble insects in size, shape, life cycle, and habits. Pest species are usually controlled with the same techniques and materials used to control insects. Let's take a look at arachnids. These would be ticks, scorpions, spiders, and mites have 8 legs and only 2 body regions. They are wingless and lack antennae. The metamorphosis is gradual and includes both larval and nymphal stages. Eggs hatch into larvae, 6 legs, which become nymphs, 8 legs, and then adults. Ticks and mites have modified, piercing, sucking mouth parts. Spiders and scorpions have chewing mouth parts. With crustaceans, we'd be talking about sow bugs and pill bugs, water fleas, and wood lice. They have 14 legs. They are wingless and contain only one segmented body region. They have 2 pairs of antennae and chewing mouth parts. Sow bugs and pill bugs have a hard, protective shell-like covering and are related to the aquatic lobsters, crabs, and crayfish. The metamorphosis with these is gradual, and there may be up to 20 instars before adulthood is reached. The sow bug has a pair of tail-like appendages which project out from the rear of its body, while the pill bug has no extreme posterior appendages and can roll up into a tight ball when disturbed. Sow bugs and pill bugs are scavengers and feed mainly on decaying organic matter. They occasionally feed on young plants, but the damage inflicted is seldom significant. Sow bugs and pill bugs thrive only in areas of high moisture and tend to remain hidden under objects during the day. Around buildings, they are common under mulch, compost, boards, stones, flower pots, and other items resting on damp ground. Another frequent hiding place is behind the grass edge adjoining sidewalks and foundations. Sow bugs and pill bugs may leave their natural habitats at night and crawl about over sidewalks, patios, and foundations. They often invade crawl spaces, damp basements, and first floors of houses at ground level. Common points of entry into buildings include door thresholds, especially at the base of sliding glass doors, expansion joints, and through the voids of concrete block walls. Frequent sightings of these pests indoors usually means there are large numbers breeding on the outside close to the foundation. Since sow bugs and pill bugs require moisture, they do not survive indoors for more than a few days unless there are very moist or damp conditions. Centipedes are made up of 30 segments, each containing 1 pair of legs. They have chewing mouth parts. Some species can inflict painful bites on humans. Millipedes contain 30 segments and are cylindrical like an earthworm. The body is wingless, and each segment bears 2 pair of legs. Their antennae are short, and mouth parts are comb-like. Millipedes feed on decaying organic matter, seeds, bulbs, and roots. There is no metamorphosis. Centipedes and millipedes do not change except in size between hatching and reaching the adult stage. Looking at the development of arachnids, which would be ticks, scorpions, spiders, and mites, they have 8 legs and only 2 body regions. They are wingless and lack antennae. The metamorphosis is gradual and includes both larval and nymphal stages. Eggs hatch into larvae, 6 legs, which become nymphs, 8 legs, and then adults. Ticks and mites have modified, piercing, sucking mouth parts. Spiders and scorpions have chewing mouth parts. As you can see with the images on the screen here, arachnids, spiders, ticks, mites, and scorpions, if we look at the black widow, you're going to see 4 pairs of legs, 2 body regions, cephalothorax, abdomen, and no antenna. And the photos here also show eggs of the black widow spider. Speaking on the black widow spider, venom from its bite can cause reactions ranging from mild to painful and serious, but death is very unlikely, and many symptoms can be alleviated if medical treatment is obtained. Anyone bitten by this spider should remain calm and promptly seek medical advice. It is helpful if the offending spider can be caught and saved for identification. The typical adult female black widow has a shiny black body, slender black legs, and a red or orange mark in the shape of an hourglass on the underside of the large round abdomen. The body, excluding legs, is 5/16 to 5/8 inch long. The adult male widow is 1/2 to 2/3 the length of the female, has a small abdomen, and is seldom noticed. The male black widow does possess venom, but its fangs are typically too small to break human skin. Black widow web and egg sacs. The web of the black widow is an irregular, tough-stranded, sticky cobweb mesh in which the spider hangs with its underside up. During the day, it often hides under an object at the edge of the web or stays in a silken retreat in the center. The black widow may rush out of its hiding place when the web is disturbed, especially if the egg sacs are present. The egg sacs are mostly spherical, about 1/2 inch long and 5/8 inch in diameter, creamy yellow to light tan in color, opaque and tough and paper-like on the surface. A female may produce several egg sacs. Tiny, young black widows, which are nearly white in color, disperse to new locations by ballooning and infesting new areas. Black widows, where the spiders live. They and their associated webs usually are found in dark, dry, sheltered, relatively undisturbed places, such as among piles of wood, rubbish or stones, in culverts, hollow stumps, and old animal burrows, in garages, sheds, barns, crawl spaces, utility meter boxes, and outhouses. And sometimes among plants, people are most likely to be bitten when they disturb the spider while they are cleaning out or picking up items in such places. A sensible precaution is to always wear gloves and a long-sleeve shirt when working in areas that have been undisturbed for a time and where there are good hiding places for spiders. Arachnids, spiders, ticks, mites, scorpions, 4 pair of legs, 2 body regions, cephalothorax, abdomen, no antenna. On the current slide you can also see we're showing the eggs of a brown widow spider, and on the right side of the screen we're showing an adult brown widow spider. On the current slide you're seeing more photos of the brown widow. You've got eggs, you've got adults, and it also shows you some close-ups of the markings on their body. Continuing our discussion of the brown widow, talking about the description of the brown widow, unlike its starkly black and red colored relative, the black widow, the coloration of a brown widow consists of a mottling of tan and brown with black accent marking. In mature females, there is usually a dorsal, longitudinal, abdominal stripe and 3 diagonal stripes on each flank. At the top of each diagonal stripe, there is a black mark, which is rather conspicuous. The brown widow spider does not have an hourglass, but is typically an orange shade rather than the vivid red of a black widow. The brown widow looks similar to the immatures of the western black widow spider, the latter of which has smaller black spots on the top of the diagonal abdominal stripes and more olive gray background coloration. Being able to discern brown widows from immature black widows is therefore difficult and requires some experience. The egg sac of a brown widow has multiple silk spicules projecting out from the surface. The egg sac has been described as looking like a large pollen grain or a World War II harbor mine designed to blow up ships. The egg sac of the brown widow spider is so distinctive that it is readily recognizable. Reproduction. Brown widows are prolific breeders, in that they can produce many egg sacs in a lifetime, often several in quick sequence. They lay about 120 to 150 eggs per sac and can make 20 egg sacs over in a lifetime. In comparison, the large western black widow spiders lay about 300 eggs per sac but make 10 or so egg sacs before they die. Habitat preferences of the brown widow. The brown widow builds its web in secluded, protected sites around homes and in woody vegetation with branches. Some typical sites selected by brown widows for web building are empty containers such as buckets and nursery pots, mailboxes, entryway corners, under eaves, storage closets and garages, recessed hand grips of plastic garbage cans, undercarriages of motor vehicles that are stationary for long periods, and the undersides of outdoor furniture and wrought iron railings. They choose places that are more exposed than sites chosen by black widows and hence appear to be at higher risk for interactions with humans as for bites are concerned. On the current slide, you're seeing a couple images of a brown recluse spider and its distinct body shape and markings. The brown recluse, also known as the violin or fiddleback spider, due to the distinctive marking on the dorsal side of the cephalothorax. The adult spider is 3/10 to a ½ inch long, and the color ranges from yellow to brown. Unlike the black widow, both sexes are present and both are poisonous. Bites from the brown recluse occur less often than the black widow, probably due to the secretive nature of the spider. Most bites happen when the victim puts on some occasional clothing like a raincoat or rolls over on a spider in the bed. Produces a cytotoxin venom which causes dead tissue, resulting in an ulcerated sore that is slow to heal. On this screen you're seeing arachnids, which are spiders, ticks, mites, scorpions. They're going to have 4 pair of legs, 2 body regions, cephalothorax, abdomen, and no antenna. And as you can see up on the left, we have a black-legged tick. Down at the bottom left, we have bird mites, and on the right, we have a scorpion. Scorpions are very distinctive arthropods. Their large pinchers are used for climbing, holding prey, defense, or courtship and mating. The stinger, located at the end of the long, narrow tail, is used for defense or to kill prey. Scorpions, arachnid species characterized by a segmented, curved tail tipped with a venomous stinger at the rear of the body and a pair of grasping pinchers at the front. Although scorpions are most common and diverse in deserts, they also live in many other habitats. Scorpions are relatively large among terrestrial arthropods, with an average size of about 6 centimeters or 2.5 inches fully grown. Scorpions exhibit few sexual differences, although males are usually more slender and have longer tails than females. Unlike most non-mammalian animals, scorpions are viviparous, giving birth to live young instead of laying eggs. Once fertilized, the eggs are retained in the female's body, where the embryos are nourished in utero for periods varying from several months to a year. Scorpions. As in all arthropods, growth is accompanied by molting. Scorpions molt an average of 5 times. The range is 4 to 9 before reaching maturity. The number of molts in some species is variable. Scorpion species vary from state to state, but the biology, habits, and treatments are similar. Scorpions are largely nocturnal and hide during the day in the confines of their burrows, in natural cracks, or under rocks and bark. Individuals become active after darkness has fallen and cease activities sometime before dawn. Because scorpions fluoresce under ultraviolet light, nighttime inspections are sometimes required. Scorpions feed on a wide range of small animals, including crickets, spiders, caterpillars, and centipedes. They have very poor vision, so they often lie in wait for prey, grabbing anything that wanders into their area. Development from birth to the adult stage may take more than a year. Mature individuals, up to 2 5/8 inches long, may live for another 2 years. Most scorpions are sit-and-wait predators that remain motionless until a suitable victim has moved into an ambush zone. Scorpions can sense tiny ground vibrations, and some can detect airborne vibrations of flying insects. These behaviors are sophisticated to the extent that scorpions can determine the precise distance and direction of their prey. Once the prey has been detected, the scorpion turns, runs to the prey, and seizes it. The prey is stung if it is relatively large, aggressive, or active. Otherwise, it is simply held by the pedipalps as it is eaten. Scorpions lack conventional jaws, and their feeding habits are unusual. An additional pair of pincher-like appendages, chelicerae, are toothed, and with these tools, as well as the sharp edges of adjacent jaw-like structures, maxillae and coxae, the scorpion chews the prey as quantities of digestive fluid secreted from the midgut pour over it. The victim's soft parts are broken down, liquefied, and sucked into the scorpion's stomach by a pumping action. The victim is gradually reduced to a ball of indigestible material which is cast aside. Eating is a slow process, often taking many hours. Scorpions can be accidental invaders in homes and buildings where they may crawl into or under any object that affords some protection. Gaps around doors are a major entryway for these wandering hunters. Exclusion for scorpions is similar to rodent and general pest exclusion. Prevent entry by sealing and weather stripping around thresholds and plug gaps where utilities, wire, and pipes enter the structure. With scorpion control, control will vary from one location to another. In rocky landscape, applying a residual product such as Delta Dust, Tempo 20 wettable powder, microencapsulated formulations, suspension concentrates. Applying the treatment under and around crevices and gaps under rocks, in and around piled brush or scrap metal piles and similar areas will aid in control. Sticky boards placed along wall edges and under furniture can capture scorpions and provide a relatively long-term, non-toxic control method. Placing sticky traps and covers work well along the interior of garage walls. Some sites may provide so many natural, outdoor habitats that reduction, rather than elimination, is the only alternative. Scorpions. Sticky boards placed along wall edges and under furniture can capture scorpions and provide a relatively long-term, non-toxic control method. Some sites may provide so many natural outdoor habitats that reduction, rather than elimination, is the only alternative. Diplopods, millipedes, are elongate, usually rounded bodies. Numerous body segments, typically around 50, appear to have two pairs of small legs at each segment. And on the screen you can see a photo of a millipede. Chilopods, centipedes, are elongate, flattened bodies. 14 to 20 body segments appear to have one pair of legs at each segment. The image on the screen is a centipede. Insect growth. All insects begin their development as eggs produced by the adult female. Although a few species, such as aphids, may also appear to give live birth, this occurs from the eggs hatching inside the mother. After egg hatch, insects grow in a series of distinct stages. Each stage or instar is separated by a period of time. When the insect sheds or molts, its exoskeleton, which is produced during molting, is larger than the previous one. A few hours after a molt, the new exoskeleton becomes hardened, and there is no further change in body size until the following molt. Insect growth. Body parts that remain soft, such as the thorax and abdomen of caterpillars, may expand to a limited extent during an instar stage. All growth ceases following the final molt to the adult stage of the insect. A small fly will remain a small fly. It is not a baby or large fly. The housefly Musca domestica, family Muscidae, is one of the most cosmopolitan of insects and has been indicated as a pest for centuries. The housefly measures 4 to 7.5 millimeters long and can be distinguished from other similar flies by the 4 dark stripes on the thorax and the yellowish abdomen with dark markings. The housefly can transmit dozens of diseases including diarrhea, dysentery, polio, typhoid, and salmonella. If the fly comes into contact with the pathogen and then passively moves the organism into contact with humans. These diseases can also be spread, perhaps just as easily, by skin contact or in contaminated food or water. Houseflies are called field flies because of their habit of breeding in excrement or rotting plant materials. Housefly populations can build up to huge numbers depending on the magnitude of the food source and can be particularly troublesome around poorly managed poultry or other livestock operations where dung accumulates and is saturated with moisture. The little housefly. The little housefly, Phania canicularis muscidae, characteristically hovers and flies to and fro in the shade of trees, porches, patios, and open garages. It sometimes flies through open doors and enters buildings. Seldom landing on human food,
it is less apt to contaminate food than the housefly. Maggots develop from eggs laid in well-decayed vegetable matter or an excrement from animals such as rabbits, poultry, and pigeons. The life cycle requires about 24 days to complete. The blowfly. Blowflies are larger than common house flies. Several species are characterized by shiny, metallic colors, either black, blue, green, or copper. In flight, they make a loud, droning buzz. Females lay eggs on exposed meat and dead animals. Meat infested by their larvae is said to be fly-blown or just blown. The larval development of black and blue blowflies requires 10 to 15 days. Flesh fly. Flesh flies look like overgrown houseflies. The more common ones have a checkerboard pattern on the abdomen. They deposit living maggots rather than eggs in decaying flesh and excrement, especially dog droppings. The flesh fly needs only 8 days to complete its life cycle. Other common sources include animal carcasses and dead snails. Insects undergoing simple metamorphosis have 3 basic life forms: egg, nymph, and adult. The nymphs typically pass through these 3 to 5 instars. Nymphs and adults often live in the same habitat, with the principal changes during metamorphosis being size, body proportions, and the development of wings. Some insects which undergo simple metamorphosis include grasshoppers and crickets, earwigs, the true bugs, Hemiptera, aphids, and related insects. Insects that undergo complete metamorphosis pass through 4 basic life forms: egg, larva, pupa, and adult. Caterpillars, maggots, and grubs are typically examples of larvae. During the larval stage, there may be 3 to 7 instars, during which the larvae usually feed. The pupal stage, cocoon, puparia, chrysalid, is a non-feeding stage. During that stage, the insect changes to the adult form. Adults are usually winged, and they may differ from the larva in several ways, including type of legs, mouth parts, and feeding habits. Adults of insects undergoing complete metamorphosis are very different from larvae and may be found in very different habitats. Insects with complete metamorphosis include butterflies and moths, beetles, flies, and lacewings. Ants. Ants are social insects that produce a colony made of various specialized types of individual ants. Most ants are known as workers. They are wingless, do most of the food foraging and rearing of young, and defend the colony. Eggs are produced by the large queens, which have wings until after they have mated. Smaller winged ants found in colonies are the males. Ants. Ants are characterized by having a very narrow, pinched waist and antennae that are bent or elbowed. They are sometimes confused with termites, especially when swarms are produced. However, termites have a broad waist and beaded antennae. Development of ants involves complete metamorphosis. Eggs are extremely small. The developing larvae are fed by the worker ants and pass through several molts before pupation. The pupa don't feed and are immobile, soft, and white. Ant nests, usually, are produced underground, and colonies can contain tens of thousands of workers. The larger carpenter ants build nests in wood, usually wood that is partially decayed. Ants feed on a wide variety of different foods. Sugary materials are preferred by some species. Others mostly feed on fatty or protein-rich foods. Some ants are important predators of insect pests. However, problems with ants often occur when they forage for food indoors during the warmer months. In addition, carpenter ants can cause structural damage. Carpenter ants, Camponotus sp. Carpenter ants are the largest ants, 1/4 to 1/2 inch. Often they are black or dark brown, although some eastern plain species are lighter in color. The most distinctive habit of carpenter ants is their nesting in wood. The ants excavate galleries and pile coarse sawdust at the nest openings. Unlike termites, carpenter ants don't eat wood. Instead, they scavenge on dead bodies, insect honeydew, and other materials. Carpenter ants almost always nest in wood that is soft because of water and decay damage. Rarely does damage extend from nests originating from damaged wood into sound wood, causing structural damage. Carpenter ants don't sting, but they can produce a mildly painful pinch from their jaws. Harvester ants, Pogonymemex sp. Nests of harvester ants are very conspicuous since they often produce large mounds. The ants are fairly large and red or dark brown in color. Harvester ants primarily feed on seeds and may clear the vegetation from the area around the mound. They rarely enter homes. Harvester ants have a mildly painful sting. Field ants, Formica sp. There are a great many species of field ants. These ants are medium-sized, and they may be brown, red, black, or any combination of these colors. Nesting occurs outdoors, often near pavement. The ants are attracted to sweets. Cornfield ants, Lasius sp. Nests of the cornfield ants occur in fields and around homes. Typically, nesting sites in yards include brick or stone walls, cracks in the pavement, beneath rocks, and sometimes in openings around foundations. They don't nest in the house, but they often forage inside in search of sweet materials. Pavement ant, Tetramorium caespidum. The pavement ant can be one of the most frequent nuisance ants in some areas. They are small, blackish-brown ants with pale legs and antennae. As the name might suggest, pavement ants commonly nest under pavement slabs, especially next to lawn areas. Rocks and areas under slab construction homes have also been commonly used as nesting sites. Foraging in the home most commonly occurs during summer, but nests adjacent to homes can allow for foraging to occur year-round. Pharaoh ant, Monomorium pharaonis. One of the most persistently annoying and hard to control ants in homes is the pharaoh ant. Pharaoh ants are very small and yellow, pale red. Unlike most other ants, pharaoh ants have adapted well to nesting indoors, and colonies may spread throughout a building. In addition, pharaoh ant colonies readily split into smaller colonies when disturbed. Pharaoh ants have a wide range of foods that include jellies, grease, cake, and pet food. Thief ant, Solenopsis molesta. The thief ant is one of the smallest ants found within a building, similar in size to pharaoh ants. However, its habits differ considerably from many other ants since it primarily develops in association with colonies of other ant species. Because of their small size, thief ants can move around in small tunnels of other ant colonies and may move about and kill other immature ants. Within homes, thief ants forage on greasy foods. Nests can occur in a wide variety of locations, but they are almost always located outdoors. General ant control. Sanitation is an important aspect of any ant control program. Crumbs, grease, food scraps, and other foods attractive to foraging workers should be eliminated. Heavy infestations of ants in buildings are rarely found where thorough sanitation is practiced. Sanitation is also important to increase the effectiveness of ant baiting. Most species of nuisance ants nest outdoors. Perimeter treatments with residual sprays applied around foundations can prevent many ants from foraging indoors. General ant control. For more permanent control, nests can be located and attacked. Dust are usually more effective for this than sprays, since the dust are more readily tracked into the colony. Also, slow-acting insecticides such as baits are the most useful, since they allow the forager time to return to the nest so the poison can be fed in the colony, killing queens and young. Control of some ants, such as carpenter ants and pharaoh ants, requires more specialized treatment. For effective control of carpenter ants, finding the nest is the ideal solution. If the nest can't be found, there are other alternatives. Carpenter ant baits are available, and there are residual products for treatments that can substantially drop the colony population. When carpenter ants are found in a building, they are either nesting inside the building or nesting outside of the building and entering to forage for food. In some circumstances, an entire colony may migrate from one nesting site to another to areas of wood associated with high moisture. Critical areas include clogged drain gutters, poorly fitted or damaged siding and flashing, wood shingle roofs, hollow porch posts and columns, and leaking doors and window frames. Look for wood in contact with soil and wood in crawl spaces or under dirt-filled slab porches. Finding carpenter ants, piles of wood debris ejected from the colony. This debris has a shredded quality that looks somewhat like shavings found in pencil sharpeners. It's similar to that produced by some wood-boring beetles that are common in firewood. Sometimes this debris is deposited in the voids in the wall and isn't visible. 2. Windows or small openings to the nest. Windows may not always be present, since existing cracks may be used by the ants. 3. Ant activity. The ants often forage in kitchen pantries, garbage, and other areas for food. Often relatively few ants are seen during the day, as they are more active at night. Swarmers. These may be found trapped in spiderwebs. Damaged timbers. The surface may appear solid, but by sounding, the damaged areas can be located. Sound detection is sometimes useful in carpenter ant nest location. An active colony at times produces a distinct, dry, rustling sound that may be heard from outside the nest. Sometimes the noise is very loud, but generally it can only be heard when conditions are very still and outside noises are at a minimum. Control of carpenter ants indoors should involve elimination of high moisture conditions that provide wood conditions suitable for carpenter ant nesting. Control of carpenter ants indoors should also involve insecticide application to nest and nest areas. Dust are especially effective in treating nest galleries. Nest treatments may be used with dust or in conjunction with sprays. However, spraying or dusting the infested area with residual insecticides without locating or treating the nest itself usually doesn't result in complete control. The insecticide should be applied to reach, as much as possible, areas inhibited or traveled by the ants. The extent of the gallery should be determined to whatever degree is practical by careful inspection and drilling. Control of carpenter ants indoors should involve baiting. If applied to areas of foraging activity, can also aid in colony control and elimination. Pharaoh ant control. Pharaoh ants are unusually well suited to nesting indoors, and most colonies will be located within buildings rather than outdoors. They are also poorly controlled with residual sprays, since irritating chemicals, including solvents and cleaners, may cause the nest to bud into separate colonies that can disperse throughout the structure. Pharaoh ant control. Use of slow-acting baits has been the most effective for Pharaoh ant control. Sweet baits, especially mint apple jelly, are readily accepted by foraging workers. However, Pharaoh ants may later become saturated by the sweet baits and no longer accept them. Use of a combination of fat-based materials, such as peanut butter and honey, in combination with sweets, are often effective for a longer period than are sweet baits alone. Pharaoh ant control. To improve bait acceptance, sanitation is essential. Failure to restrict other food sources will result in poor bait acceptance. Since the purpose of baiting is to get the ants to feed on the bait and return it to the colony, residual insecticide should not be used in the area of baiting. It is also important to avoid use of volatile cleaners and solvents, which may repel Pharaoh ants. Residual insecticides can be used as a preventative treatment in areas where ants are not present. Common household pests, cockroaches. What you're seeing here on the left is an Utica, a cockroach egg sac, and the life cycle of a cockroach on the right. Cockroaches are oval, flattened, fast-moving insects. They have long, hair-like antennae and a broad, saddle-like plate pronotum that covers the head. Adult stages of most species have wings, with the front pair being thickened and leathery. Cockroaches go through gradual metamorphosis with 3 basic stages in their life cycle: egg, nymph, and adult. The eggs are laid in bean-like egg capsules called ootheca, which may contain several dozen eggs. Cockroaches. These egg capsules are often dropped around food sources or glued to surfaces, although some cockroaches carry the capsule during its development. The immature stages are called nymphs. Several nymphal stages occurred, each separated by a molt. The nymphs generally appear like the adult stage, but they lack wings and are smaller. Typically 2 or 3 months pass while they complete their life cycle. Cockroaches. Cockroaches are among the oldest group of insects known, with fossils dating back 200 million years. As a group, the cockroaches have shown exceptional ability to adapt to and survive in a wide range of environments, including human dwellings. Most cockroaches can develop on a wide range of food, and their flattened body form allows them to move into most areas. Cockroaches have also developed a high level of resistance to commonly used insecticides. Cockroaches. Cockroaches can enter buildings and containers of many kinds. They also may enter around loose-fitting doors and windows and through utility lines, and they may travel through sewers. Once within a home, cockroaches tend to prefer warm, dark, moist shelters and are often found near kitchens and food handling areas. Since cockroaches are nocturnal, they are rarely seen during the day. Cockroaches. Aside from their importance as a household nuisance, they may soil areas with their salivary secretions and excrement, leaving an unpleasant odor. Cockroaches and cockroach parts also produce allergic reactions in some humans. Cockroaches haven't been found to be direct carriers of human disease. However, their habits of feeding on filth or diseased organisms make them well suited to mechanically contaminate food or utensils. They are suspected of helping to spread diseases such as dysentery, diarrhea, and food poisoning. German cockroach, Blatella germanica. Adults are pale brown to tan and about 1/2 inch long. Adults have wings and are distinguished by having 2 dark stripes that run lengthwise along the pronotum behind the head. This species has the highest reproductive potential of the house-infesting cockroaches. Females carry their egg capsule protruding from their abdomen until the eggs are ready to hatch. German cockroach, Blatella germanica. Females produce about 4 to 8 capsules in their lifetime. Each capsule contains 30 to 50 eggs, which hatch in about 28 days at room temperature. The eggs usually die if the mother is killed. Females live an average of 250 days. German cockroach, Blatella germanica. German cockroaches will generally be found close to moisture in food, such as in kitchens and other food areas, restrooms, and around plumbing fixtures. Surveys should concentrate in cracks and crevices, under tabletops, behind sinks, in cabinets, in motor areas of refrigerators, in and around kitchen equipment, and similar sites. Infestations found scattered throughout a building, including non-food areas, indicate very high populations. Brown banded cockroach, Supella longipalpus. Brown banded cockroaches are the smallest of the more common cockroach, slightly smaller than the German cockroach. Brown banded cockroaches vary from light tan to glossy dark brown in color. The adult stages are marked with 2 light-colored bands at the base of the wings. Brown banded cockroach, Supella longipalpus. Brown banded cockroaches usually glue their egg capsules to surfaces in dark areas, such as cabinets, chairs, boxes, drawers, and high areas of a building. Because of this habit, they are easily transported to new buildings. Females produce about 14 capsules during their lifetime, averaging 18 eggs in each capsule. Eggs hatch in about 50 to 75 days. The adult female may typically live about 200 days. Brown banded cockroach, Supella longipalpus. Brown banded cockroaches tend to scatter thoroughly through a building. They prefer areas of higher temperature, 80 degrees Fahrenheit or higher. Brown banded cockroaches tend to occur more often in homes, apartments, hotels, and hospitals than in stores or restaurants. Oriental cockroach, Blatta orientalis. Oriental cockroaches are not as common as the brown banded cockroach and the German cockroach. Oriental cockroach, Blatta orientalis. Adults are about 1 inch long and dark brown or black in color. Wings of the Oriental cockroach are short. Females only have small wing pads, while males have wings that only cover about 3/4 of their abdomen. Females drop egg capsules in warm, sheltered areas near a food supply. Each female produces an average of 8 egg capsules, each containing about 160 eggs. Under room temperature conditions, eggs hatch in about 60 days. Oriental cockroach, Blatta orientalis. Adult females may live about 180 days. Oriental cockroaches are almost always found around moist, dark sites. Common habitats include floor and storm drains, water meter boxes, around plumbing fixtures, moist crawl spaces, sewers, and around garbage. Oriental cockroaches may be found outdoors during the warmer months of the year. Oriental cockroaches are rather sociable, and clusters of them may be found in favorable habitats. They are seldom found on high walls, in high cupboards, or in the upper floors of buildings. Oriental cockroach, Blatta orientalis. Detection. The site should be thoroughly surveyed to determine the extent of the infestation and to identify the type of treatments that will be required. Fundamental to this is determining the cockroach species present. Since different cockroach species have differing habits, this will allow treatments to be better targeted. A search should be made of all suspected hiding places. Since cockroaches are less active during the day, this can be difficult. Flushing sprays of pyrethrins can be used to irritate cockroaches and cause them to move out of their hiding areas. Oriental cockroach, Blatta orientalis. Sticky traps or glue boards can also be useful to help detect cockroach activity and monitor the successfulness of a treatment. Several different types of traps exist, and some also contain the sex-attractant chemicals used by certain cockroach species. These traps should be placed in areas where cockroach activity is suspected, and they should be checked after a few days. Traps can also be used to help control cockroaches, but they aren't an effective substitute for other control practices. Oriental cockroach, Blatta orientalis. Sanitation is fundamental to cockroach control. Any methods that can be used to deny cockroaches the food, water, and shelter they need will greatly aid in control. Cleanliness and good housekeeping are essential. Food should be kept in tightly closed containers and should not be left exposed. This includes spilled materials, garbage, food scraps left in the sink areas, and pet foods. Water is an important need of cockroaches. Oriental cockroach, Blatta orientalis. Dripping faucets, leaking pipes, and other sources of moisture should be eliminated. Bottles and cans to be recycled should be stored outdoors if possible. Sewer openings should be screened. It is also important to remove potential sources of reinfestations. Cracks, crevices, and other openings should be sealed. Pipes should be caulked and sewer drains screened. All materials being moved into the building should be checked for evidence of cockroach infestation. Control. Several approaches to chemical control are possible. Regardless of the chemical or formulation chosen, applications made near regular hiding and breeding places will be most effective since they allow more contact. Chemical controls usually provide only temporary suppression, especially when they aren't combined with a vigorous sanitation effort. Another serious limitation of insecticides is the development by many cockroaches of resistance to the chemicals. Many populations of German cockroaches are no longer susceptible to several insecticides that formerly were effective. Control. Cockroaches are repelled by several chemicals and will avoid treated surfaces. Often, where no previous control has occurred, the initial treatment consists of a thorough cleanup or clean out. During this treatment, sprays or dust are applied thoroughly throughout the building. As a result of this thorough treatment, there is often an immediate reduction in cockroach numbers. However, cockroaches are rarely eliminated by a single treatment, since egg capsules aren't killed. Also, some cockroaches may remain hidden in or migrate to untreated areas. Vacuuming is almost always the best first treatment option to quickly reduce the population and prevent scattering of the infestation. Monitoring with sticky traps or glue boards can help determine the success of the treatment. Sticky traps with food attractant. Sticky traps are a great way to identify areas of infestation and to monitor areas after treatment. Control. Control chemicals can be microencapsulated formulations, dust, insect growth regulators, IGRs, or baits. Choice of the type of treatment should be matched to the conditions of the infestation site. Treatments may involve sprays or crack and crevice treatments to provide a residual effect. Treatment. These applications leave a toxic residue on the treated surface that cockroaches pick up when moving across it. The length of time that treatments remain effective varies depending on such factors as the concentration of the chemical applied, choice of insecticide, and application surface. 2 to 4 weeks of residual activity is fairly typical with baits, dust, and IGRs lasting longer. Sprays should be applied to cockroach harborages with thorough emphasis on cracks and crevices. Avoid runoff and immediately wipe off excess spray. Oil-based sprays shouldn't be applied near open flames, to tile floors, or onto plants. Water-based sprays shouldn't be used near electrical outlets. Several precautions should always be taken when making insecticide applications for cockroach control. Pets should be removed from the treatment area during application, and all aquariums should be covered. If sprays are to be applied to areas where food, cooking utensils, or dishes are stored, these items should be covered or removed prior to treating. Furthermore, applications around these sites must be limited to cracks and crevices, avoiding exposed areas. Also, treatments made near air ducts and ventilation systems should be done with extreme care to avoid air contamination. Dust can penetrate cockroach hiding areas that sprays may not reach. They are also useful on rough surfaces or on surfaces that would absorb liquid sprays. They may kill the insect by having the chemical penetrate the insect body or be swallowed as the cockroach cleans its antenna and legs. When applied to dry locations, they also last longer than residual sprays. Dust should be applied as thin films, since heavy concentrations can repel cockroaches. Some dust, such as boric acid, may be applied in water, which quickly dries, but to be effective, dust must remain dry. Dust are not appropriate for use in areas where they would be unsightly or cause contamination problems. Baits are generally long-lasting and can be applied to areas that can't be treated with sprays or dust. Often, baits may be placed inside small containers to help keep them away from pets and humans. To be effective, baits should be used in small amounts placed in many locations. Effectiveness of baits is greatly dependent on the amount of competing food sources available. If sanitation efforts haven't been thorough, baits perform poorly. I just want to mention on this slide, if any of you have worked in pest control situations where sanitation and competing food sources were an issue, baits are not going to be effective at these times. So whether you're dealing with a residential home or a restaurant or whatever the case may be, you have to make sure they have good sanitation. If not, you're not going to win the battle by baiting for cockroaches. We want to give a big thanks to bugwood.org for allowing us to use their photos and the individual photographers listed on this slide. The use of trade names in this publication is solely for the purpose of providing specific information or as examples. American Pest CEUs does not guarantee or warranty the product's name, and references to them in this publication does not signify our approval to the exclusion of other products of suitable composition. All chemicals should be used in accordance with directions on the manufacturer's label. Use pesticides safely. Read and follow all directions on the manufacturer's label.
Congratulations, you have completed the program. Please proceed to the exam.